welcome to Metaverse Inception V2.0, which will be using Unreal Engine, Houdini, some ZBrush and Maya and Substance Painter. Um, and I'll introduce Alab, who is a licensed and practicing architect based in the Philippines. Alab is currently expanding to multiple design disciplines. He's currently pursuing advanced design through computational methods. He specializes in organic and bio-inspired forms using procedural techniques. As a metaverse designer, he has worked on numerous collections and projects with a wide array of industries and holds a Master of Science in Computational Event Design from Simorphy Masters from the first year. So, welcome, Alab. Happy to have you here teaching the V2 of this course. Uh, and yeah, we'll
Hello,
let you.
excited to be back. So,
Oh, before you start, let me just mention everyone, make sure you switch your chat to say everyone if you don't know, because if you don't, then only we'll see it. Um, if you want to ask questions, you can use the Q&A button. It's near all the rest of your buttons there. And also, just a reminder that this webinar is recorded and you will get an email to watch the recording after the webinar has finished and the video has been processed, which can take something like up to a day. Okay.
all right. So, I'm Alab, and just a brief overview about this webinar. So, apologies, as this is a very new sort of approach that I came up with, and like images of this specific webinar content wasn't released until a few days ago because it kind of took long to put together. So, but it's very exciting. It puts together many different key concepts, which I will go over later, such as procedurally tiled textures, procedural forms, a hybrid approach between ZBrush and Houdini. So let's go over it. First, I'd like to go over our course outline and how we'll be spending the whole day together. First, probably, I'm not sure if it'll take this long, but we'll go over the pipeline and its key features. I'll explain each and every part of the uh, of the sections briefly. I've also, for those of you who haven't, please go ahead. I've typed out a link in the chat to download the downloadable package. So there you'll find this handout, which we can check out together, as well as the project files, which will be Houdini files, ZBrush, Substance Designer, and an Unreal Engine package as well. So we'll do that for the first 30 minutes, probably going over through the software, some installation, concept art, and reference gathering. And then for the next 2 hours or so, we'll actually create the procedural cliff together. And we'll be going through it in Houdini and then creating HDA parameters to be controlled in Unreal Engine 5. Also go through cleaning, optimization, vertex color baking, and packing. And we'll also see it in action and bake it in Unreal. Next, we'll go over the Unreal 5 materials creation, creating the parent material and instancing as well, and seeing how we can integrate Quixel textures. Then we'll have a short break. And then for the next part will be the procedural landscape, which goes over creating the landscape in as a height field in Houdini, and once exported and once integrated into Unreal, actually places a landscape which has collisions and you can walk on right away. And the next will be the architecture, just this part. And then next would be the integration between Substance Designer and Houdini, and then foliage painting, atmosphere, and rendering. So here I have an image showing like sort of the final output that we can come up with, and it shows here the part one, which is the cliff, and then part two, which is the landscape itself, and then part three, which takes part of the creation of the cliff and also adds in the creation of this architectural piece, which can be quite varied in output depending on how we how we control the parameters. And lastly, actually, part four would be the creation of procedural textures. This shows how you can, if you're more versed in Houdini than Substance Designer, you can actually create textures in Substance Design in Houdini as geometry and send them to Substance and have them output directly to Unreal Engine later on and sync it. And then lastly, we'll be creating the scene as part five and adding in the foliage, sort of painting the entire picture as as we planned initially. So some key concepts that I wanted to sort of share with you guys would be the procedurally tiled textures. So in the usual environment art pipeline, uh, you would be creating a specific asset and unwrapping that specific asset. Um, and sending it over to textures, and they would sort of paint paint the textures and sort of create the texture specifically for that asset. But in this case, which uses a procedural approach, the forms will change as well as the UVs, and we want to be able to have a texture that adapts to that. And the way to do that is, and or rather, the main challenge of that is once you get variation, once you get variation of the forms, how do you differentiate or how do you add in the nuances such as the like the edge damage, the color, the ambient occlusion parts, which parts are rusty, which parts are metallic, and all those different details in the mesh and textures, which otherwise in a conventional pipeline you would actually either paint out or do semi-procedurally in Substance Painter. So we want to do this as like as automated as possible. So we're using vertex color baking as and using the RGB channels sort of a differentiator to blend the different materials together. So if you see this image, it's, let's say the green would be the base material and the blue would be sort of um the material that sort of breaks the continuity so that you don't actually see much of, repetitiveness. So, and then the third would be the red, would be which would be highlighting the edges or the curvature. So usually in the game pipeline, it's mostly just this because like it's mostly just using our RGB because more than this you go too heavy of a the shader itself becomes too heavy that it becomes inefficient. So I think this is the most efficient process to go using RGB channels and just playing with that. So also we'll be procedurally unwrapping the cliff in Houdini. And then there are also key concepts would be procedural form generation, which would be this architecture in itself. So actually, as we went over with the cliff briefly, the cliff is sort of procedural, so it changes form. So the architecture in itself would form around the cliff. So how do you create a form that adjusts to the cliff as it iterates, and how do you iterate within that architecture in itself? But this procedural form, when we're creating the architecture, we sort of want to be able to art direct it a bit. So in those instances, that's the reason why I wanted to integrate the ZBrush approach or the sort of manual approach because in environment art pipelines, most there should still be a level of art directiveness in the workflow, not just fully procedural. So that comes to play in creating the concept art, or sometimes in the middle of the entire pipeline, you'd want to be able to sort of be in one place or in a viewpoint or a vista, looking at looking at the focal point and want to adjust certain things to your specifically to your liking, and rather than tweak the whole script to fit that certain thing that you just want, for example, drawn. um we want to have that level of control where you can art direct it right in the middle. So that's where the ZBrush comes in. We have the cliff. You want to edit the cliff in certain ways to make it fit your architecture or fit the outline that you want to create. So we'll go over that in the process of conceptualizing. So also later, I think I did go over the substance designer integration with Houdini. Um, if you want to create substance textures or textures using Houdini as as geometry, and then later using substance designer to add in some base color, ambient occlusion, normals and whatnot, and then later on output it to Unreal Engine. So that's what we're going through now. So first in our pipeline, I'll go over the pipeline. So with any art project, you begin with a reference gathering, or so. How do you put together the scene? So where do you start when putting together the scene? So in this right area, if you look, we have here sort of a mid-journey exploration, but uh in reality that wouldn't just be mid-journey. Mid-journey would probably paint like a bigger picture, and then you'd probably have smaller references. For example, the rock, the cliff. You'd want to look through some Google images of how these rocks look like in real life when you're going to zoom in into detail, and how these sort of hanging objects or stalactites would look like. So um we're not really going over it, but what I would suggest for everyone is, in this concept stage, you gather sort of a mood board, and what I would suggest for that is pure F, which I'll be opening up. So PureF is a software just like Miro, is like a whiteboard software. And what's good about this is it's if you see it here on the lower left screen. So if you don't see it, please just type it. So um this is where you actually add in your inspiration, and it will stay there no matter what window you open. So for example, you have this image. I just dragged and dropped it, the Midjourney image onto, so you're sort of creating your sort of mood board or reference board, which is really important before you go into sort of sketching things. So for example, I Google image search sort of stalactite, which we wanna sort of create later on, or some sort of icicles. So I just dragged and dropped this image. I should copy it. Yeah. So if you see, there are sort of icicles here, oops. Okay, we're back. In this sort of output, if you look at this PDF, there are sort of icicles here or stalactites that I took inspiration from icicles, which were created. So you put those images in a reference board and put them together before creating any environment art concept sketch. So after you've gathered all of your references, it's time to sort of paint closer to the direction that you want to be. For example, this was a sketch that I created when I was still conceptualizing the overall look of this webinar content. And if you look at it, I took the elements of the cliffs and I put it at the side and wanted to use it as a frame for the pathway in which the character should be moving around. It would sort of be at the sides of the image and sort of lead to the middle or the focal point, which is the architecture on a cliff. So this workflow is also used in movies wherein a concept artist is creates a concept sketch, concept art, and the production team sort of uh, paves the way to realize that. So it's very important that you have this concept art or you sort of sketch your vision before starting anything because it becomes really quick to get lost once you create an asset and get into the details. You sort of lose way of the vision, and this is one that'll sort of guide you. So I might also drag in the concept sketch that I created before here in the PureRef window. So for your mood board, just have this on. If you haven't downloaded PureRef, I'm just going to link the well, it's puref.com. So next would be the blockout stage. So typical to any environment art production pipeline, there's another professional that does the blockouts, which ensures that in games that the environment is playable. And for example, some of the heights where the heights of the assets that they don't intend the characters to go to, they're high enough as for the character not to be able to jump in them. For example, if you look at this image, in this blockout, the forms are very rough, but it sort of paints the picture in 3D about what you want to see in the end. And it shows the pathways, it shows the direction in which the character travels. And later on, once these blockouts are created, groups, these are clustered and sent into artists who then detail them and create the asset for unwrapping, texturing, and later on implementation in the game. So so after the blockout stage, I decided that the cliff parts, if you go back again to the sketch, if you look at the sketch, the cliff actually takes the most out of the real estate of the sketch. So they're about like most of the screen is cliffs. The rest is landscape and the architectural piece in the middle. So I decided to go with that first. So in this section, we'll be going about how to create this cliff procedurally, and then later on, adding vertex color baking so the Unreal Engine will able to read this vertex colors and differentiate the blending of the materials. So, for example, material 1 would funnel into the red part, 2 to the green part, and then 3 to the blue part. And the fifth portion, we'd actually test this in Unreal. So frequently, we would be doing this sort of process that we would do the asset in Houdini and then later on check if the HDA is working or the or Houdini engine is baking properly. And if our parameters were created functionally and they show up in Unreal, and basically the purpose of the HDA is to be able to send your file from Houdini to Unreal and still be able to iterate in Unreal as needed. So also another thing is the more another person relies on this HDA, because the role of technical artists in Houdini creating these HDAs are they create tools so that the environment artists will be able to manipulate them in Unreal without having to uh know the technicalities of Houdini. So we give tools that the other artists can use functionally. So we'll be testing that every now and then. And then the next part would be the Houdini height fill to Unreal landscape. We'll be going ahead and creating the actual landscape. So Houdini has these great set of tools that wherein you create this geometry, and when you package it in an HDA, it outputs as a landscape, which is a functional asset in Unreal, wherein the player can walk to. So in normal cases, if you just send in an asset to Unreal, it doesn't read the collisions yet. But in this case, as a landscape, there are collisions, and it already outputs it directly with collisions, and you can actually walk. The player can walk through it. You can test it, and the landscape material blends are if you do it properly, um, Unreal will be able to read the differentiation of the different uh materials and the vertex colors here, as we did with the first part, or part one. So next would be the architecture in itself, and briefly to explain this architecture part, this is where we took part of the cliff, and then we broke it up with ZBrush, as I mentioned earlier, and we create the architecture so it becomes from procedural to manual, or you can have a switch to have it fully procedural. We just want to have this option to create to add a manual approach or manual touches. Like should we have any artist to help us with this, or if we want a specific look, or if we want a specific outline that we can't achieve necessarily right away by controlling the procedural parameters. So, and then bringing it back to Houdini to process and unwrap, and sending it to Unreal again for the normal process. And then for the next part would be creating, it's not very in-depth in Substance Designer, but this is just showing that you can have geometry in Substance Design in Houdini, and sending it over to Substance Designer and processing them, creating pack textures. We'll be using the PBR shape sort of model of a shader, but the textures we will pack them. I'll show how they will be packed later on, but what the important part of Substance Designer is, it is able to um efficiently package the texture outputs to be used and to be synced into Unreal later on, which you can change anytime. It's a non-destructive workflow, and it's very efficient. So lastly would be the Unreal Engine setup. We'll be controlling the atmosphere, adding foliage, VFX. So some more advanced users might be wondering why not just add in the foliage in in Houdini. Actually, you can, and sometimes it can be more efficient that way. But since um we are using a very controlled scene wherein we have specific views, specific angles, not the whole map is not even close to playable. We want to be able to have that sort of handmade touch by being able to paint the foliage in Unreal Engine itself and being able to art direct it as we want. because sometimes um it it takes a lot more time to sort of craft what you want in Houdini, and in the end the art director or the the professionals who are in charge of setting the direction would want to sort of tweak, for example, create put another asset here in the middle, and you'd have to conform to that. You'd want to have that level of control and flexibility, which will be, in short, a little bit more efficient for the entire team. So I think I went over I already went over the creation of the concept. Um, I did create this in Photoshop, the concept art. You can use many different software, such as there other industry standards aside from Photoshop are Creata. You can use Paint, you can use your Sketchpad. The most important thing about this is you have this sort of blocking elements before you create the 3D blocking. You have this as a guide to your ideation. So let's check the time. I'll be going through this every now and then to check where we're at, and using this as a sort of a guideline that we can follow. So I think the first thing we'll do is we'll open up Houdini. So for those, I think I'm using Houdini 20.0.625. You can use a lower version. But I think if you download the package that I sent, you can only open it using Houdini 20. So for those who'd want to follow along, you can open the rocks cliff file, I think. Let's see. The base cliff file, actually. And then we'll be creating it together. So this will be the sort of final output of the base cliff. Just to so if you look at it, there will be three components into it later on, and so that you can have a sort of overview of this specific asset. So the first part would be the rocks in itself. Next would be the icicles and the topper, which looks like a sedimentation on top. So we will also in the end have controls in Unreal Engine whether to include these icicles or toppers or not. So let's go over them. So I'm just gonna set aside this pure ref because I no longer need it. For some of you, you can still work with the pure ref there. So I started by enlarging this graph part and then minimizing the parameters side and pressing P to open the parameters right here. So we'll start with the geometry node. And as I'd like to always name it, so it's gonna be rock cliff. It's 3 because I already have like two files of it. And let's start with the base form first, and it's a cylinder. And I'd always like to have inputs. I think this is a convention that was that we learned to have the nodes of the input nodes, like the very starting input nodes as different shapes and colors. So let's have them at a circle. So for this base form would be later on broken into a Voronoi, which we will sort of subtract and create different boulders from. So you have to, so let's turn on end caps. And then plug in an ISO offset node. So what this does is later we'll be scattering points around to define the Voronoi. And what this does is this, instead of having just the cylinder itself and having the points scatter around the surface of the cylinder, we want points to scatter inside the volume. So we're using ISO offset. Then a scatter node. So if you see with the ISO offset, it adds points even inside rather than just outside. Whereas if you just directly scatter, it's going to be all on the outer portions of the cylinder. So this cylinder is probably going to be, the length will create it as, wait, let's change it into a lab. See if it's, let's have the, let's have the height at probably 10. And we'll keep the radius at 1. So, and then you have the ISO offset, then the scatter, and then let's put in a Voronoi fracture. Let's see what this does. So actually, we need the geometry itself to fracture and the points for the cells. So to me, this seems a little bit the fracturing seems a little bit small, so we're gonna adjust the scatter. So let's put the force, instead of having it to force total count, let's put it into density scale instead. Let's put it at probably 8. And this global seed would actually control the differentiation of the scatter points. See, let's see the global seed. When we change the seed, the scatter points will change as well. So later we will be referencing this into the HDA to have sort of differentiation. Don't forget to save your file. And then next would be an assemble node. So we need to add assemble node so that the Voronoi pieces would be bound as objects, because if you don't, they would be just faces separated to one another. So, and then next, what we want to do is to be able to sort of remove the outer objects and just have the middle retained, so that we come up with a sort of boulder stacking form. So for that, I'm gonna add in a transform node. And then this transform node has like a sort of smaller scale, 0.6 at the X and the Z axis, so that it's sort of getting just, we're going to select just the inner volume. And then we're gonna add a group node. And this group node will go over the primitives. So so we're grouping this as an object, and then what we want to do is get the form that we created earlier, and then use this as a selector. So include bounding regions, keep bounding regions, and bounding objects. And it says here, select bounding option works with point groups. We're gonna change the group type from primitives to point groups. And then we're gonna blast. We're gonna blast whatever is not in that group. So let's see if it works. So group 2. Oops. Let me see. I think I missed so this is what happens if the blast doesn't work properly. It's not actually, I mean, the assemble doesn't work properly. It doesn't pack it into specific boulders as one. So let's check. Probably you have to check. I forgot to check create pack primitives. So once we do this, we're sort of packing the boulder forms into one each and stacking them so that when we delete, we only delete the objects that are outside of it. So next, I wanted to add a sort of control that when you're in Unreal Engine, you want to reduce uh even further the number of the boulders that are included. So for that, I just want to create a group that you can adjust the height. So let's see. So I'm gonna plug in a bound. This gets the bounding box of the selection transform node. And then I want this transform node to have like to be in smaller in scale. So let's make it 0.5. And then I want to again select that and blast. So let's see. So we're going to keep by bounding regions again and have that 2 points. So bounding regions, bounding object will change this bounding type to bounding object. So if you see this green part is selected, and then we're going to promote so that it won't just select the faces. We're going to promote this group from points to primitives. So, and then specify the group name group 3. So we select this area. And then again, we're going to blast everything that's not included. So this functionality that I included, you will be able to select the area of or the height of the assembly that you want to keep. So let's plug in the blast node and reference the group that we just created, which is group 3, and then check on delete non-selected. So I'm gonna show from smooth shaded to wire shaded. Right now it doesn't display the edges yet because it's still an assembly. So we have to unpack that assembly which we created so that we can manipulate within that. So let's add an unpack node. And then I wanted to add a clip node that sort of ensures that the base is always flat. In this case, it didn't remove these parts at the corner, so it kind of looks flat. But in other, let's try other seeds, for example, this probably won't be as flat. So I wanted to add a clip node. And so if you see this parameter, this distance parameter, this sort of, if you increase it, the clip region would actually go up or down. So if you see it, if you press enter while highlighting the clip node, you can see where it is. So after clipping, always a good measure. We can add this to the functionality of the HDA later on. Always a good measure to have to close the polygon that we clip. So let's have a polyfill node. And then have it from quadrilaterals to single polygon. So after that, if you see the normals are sort of junky here, so we're gonna fix that later on. But first, you have to delete all of those that all of the small objects that are not attached here. So sometimes in the Voronoi process, you can have objects that are not connected. So just a good measure to have the delete small parts node, labs delete small parts, and extract the largest, not the largest piece, but have a threshold sort of to delete the smaller pieces that are not there, just as a cleanup. And then, because we sort of clipped it, we want to have a match size node, which will put it back into the origin plane. So when I'm putting a match size and aligning it to the horizontal plane, I always check the justify X and Z to none, put it to none, because we're just wanting to adjust the Y. So changing the justify Y to, I think, min, yeah. So we got that. Minimum means like the lowest value of the Y. So with that, it always aligns it to the horizontal plane. And then after that, to fix this, we're gonna add a normal slope. It's good to always like sort of spot these geometric errors early on and address them, such as these normals. So once we add the normals node, we actually, when you add the normals node, it sort of smooths the other angles that we don't want. So what we want to do is decrease the cusp angle so that everything will be sort of sharper as needed. So we have a threshold in which it smooths it. It smooths the geometry and where it doesn't. So if you want everything sharp, go all the way to 0. So there, we have everything sharp. So that's where we sort of close the first part of the first section of the geometry. So we're going to create a network box for that, color it differently, and name it base one. All right. Next, we want to add a little bit more detail by referencing or taking away some parts of splitting some of these rocks and breaking them down even further for smaller rocks. So what we're going to do is we're gonna have the delete small parts node again, but instead of instead of having it actually delete anything, we're gonna have it as a group. So let's see first what sort of uh we'll use it as a separator. So let's see what can you do to play. So I'm gonna raise the threshold until we get to a point that we see just like a few pieces. So let's go with probably 2.5. So we see a few pieces that are actually separated, and we're going to use that instead of deleting, we're going to use that we're going to check group instead of delete. And then we're going to add in a split node so that we can separate those two geometries and split the selection. So if you see to check this properly, we're going to create put nulls here. So once you highlight null one, we'll see this. When you highlight null two, that's the second portion. So for the first part, we're gonna do the same process but on a smaller scale on how we sort of broke down the bigger form. So again, we'll use ISO offset. So it turns it into sort of a cloud that you can scatter points on, and then a scatter node. Let's have the density scale at 500. And the ISO offset, let's have it at negative 0.07. So what this does, it brings the volume in so that you have smaller amount of pieces or points. And then as we did before, we're going to do the Voronoi fracture. So plug in this main form and plug the points into the second node. So we have this. And then we are going to assemble as we did. So don't forget to check create back primitives. This is what it does. And again, we are going to create forms that delete the outer parts or just select the inner parts as we did initially. So we're going to treat each of these boulders as the main form that we did earlier. So we're gonna add in for each loop, for each connected piece, plugging in the second split node. No, actually, the second split node will go, the second split node, the second part will be the smaller pieces and everything else will be continued. So what we're going to do is we're going to plug in all of the second inputs to this one because we're only dealing with the second inputs. Let's put this aside here and make sure none of the first input is funneled in here. So I'm gonna add in so what this does is it references piece by piece and we're going to manipulate piece by piece. So I'm gonna add in a transform node. And I want to sort of, if you look at this, if you try to scale it, this will scale from 0, 0, 0. So I want it to procedurally look at every piece and scale it from the very center of each of that piece. So the way to do that is to go to the pivot translate and $CEX or central of the center point of the X part, and then CEY, $CEY, and then dollar CEZ. So this sort of approach to transforming things from their centroid is is a very used node, so you might want to sort of put this in your shelf by dragging this transform node into your shelf so that you can use it again later on. So let's see. So let's put this in the create tab or the modify tab. So transform. Let's name it transform centroid. Put here and then delete this tool. So transform centroid at your modify tab. Let's go back here again. And then we want a sort of uniform scale that's sort of smaller than the original one, so we can select the inner part. So let's go with 0.74 probably. And then again group that and select based on that form. So we are going to include by bounding regions and bounding object. And then again, it gives that error. We're gonna move from group type primitives to points. Then we select the inner parts and then blast. Whatever is not group 4. So let's see. So now we're able to eliminate the outer edges and sort of a more detailed look. And then to not forget, you must unpack the geometry because you assembled it early on. And then merge the two splits. So we have the bigger forms here at the first part of the split and this part. So after that, be you'd have this form. If you notice some parts are disconnected, later on we'll be eliminating that and we'll sort of be merging all of those together. But this sort of approach helps it have some sort of variety and just not have big forms, just not have big boulders there. Okay, so this is another section that we will network box. This is another part. Let's put this as main details. Uh, for smaller. Okay, so um, what we want to do afterwards is sort of process this and bind them together. So for that, I'm gonna add a for each loop and sort of VDB every one of these pieces together. So for each connected piece, funnel this in, and then I'm gonna add a VDB from polygons node here, and then I'll make sure that the voxel size isn't that big. If you look, it's quite big, so we'll reduce it to 0.05 and then convert the VDB to a surface. So what we're doing is a kind of polishing it and eliminating the fragmented pieces and sort of binding everything together now. So convert to polygons here. And then we'll add an attribute blur to sort of make it more of a bolder shape. And you can actually skip this attribute blur, but I wanted to include this so that it would look more round and fragmented. So plug in an attribute blur. and have the iterations probably at 5. 5 will be good. So you see it shaped everything better, and I'm just gonna add a mountain node to add variety. So we don't want it, if you look at it at the end, you don't want it too aggressive, the mountain node. So we are going to reduce that amplitude from 0.2 to maybe just 0.1. Whoops, 0.1. Yeah, just to have like a sort of subtlety. So if you see before and after, some we will be eliminating this later on because it's a flying geometry. So let's head to this merge. And I will be adding a node that sort of pushes it out, the rocks together. So it will sort of have an overlapping of forms so that it will be more singular rather than fragmented pieces. So we're going to add an attribute swap. And let's go into the node by double clicking, and then I'm going to add a displace along normal just to sort of, you can also use extrude if you want, but I decided to go this method. So displace, and then the amount I'm gonna promote to a parameter so you can control it outside of this, just as this node. So we have this displacement amount here, and I'm gonna put 0.1 so you can actually have it bigger or smaller. So you see some of the geometry is already creating errors, but we'll do certain processes that eliminate that later on. So we'll have again an assemble node and back, create back. Actually not create back primitives, and delete the smaller parts. Let's have a threshold of 0.8. See if we will delete the really small parts that have errors. And then, because if you look at this the way it's looking now, it's not how I intended it to look like. So we're gonna sort of mush it vertically to have it closer to the form that I intended. So if you look at the sort of PDF again, if you look at the rocks, they're sort of horizontally sort of mushed together. And that's the sort of look that I wanted to go for. Let's go back to it. So we're gonna add the transform node to achieve that. And we will just sort of decrease the scale by 0.5 just to mush it together. And we'll have this VDB processing to eliminate those, or actually eliminate the errors and have everything bound together. So again, VDB from polygons. And have the voxel size a lot smaller, like 0.02, and then convert. And then remember to change the convert to volume to polygons. So And then from this part, we can actually already add the network box and add it as, let's say this is where we unify the form and make it one singular piece. So going back to the image, if you see that there are these actually horizontal protrusions. So I came up with a kind of a displacement that only went the horizontal direction, or a noise that went the horizontal direction, which gives this streaks. So that's what we'll do next. So I wanted to displace only horizontally, but for that to happen, we must have the normals pointing outward like a cylinder, not this, because if we do this, if we use this as the normals, some of them will um displace up, down, and we want a more controlled way of displacing it. So what we're going to do in the next section is we're going to mimic the normals of a tube. So I'm gonna add a tube. And again, as we did in any main input, we're gonna change this node, um, the node shape and the color. And we're gonna match size, because what we're gonna do is we're gonna match the tube to the form that we just created. And we want to scale to fit, and uncheck the uniform scale so everything sort of just fits together. So if we highlight this, we see that the cylinder is wrapping. That's what we want. We want the cylinder to wrap the object itself so that we transfer the normals properly inward. So for it to work correctly, if you look at this tube and we're going to look at the normals, we only have a few normals here which are going to be transferred, but we want the resolution a little bit higher so that the cliff reads it better. So I'm going to add the subdivisions. Let's make it 25 rows and 50 columns. Probably good enough. And then I'm gonna add the poly extrude just to make sure it's bigger than it's because if you look at it now, it's sort of just hogging it, but I want to ensure that it's always bigger than the cliff. So we're gonna add the poly extrude node and add distance to probably 0.3. Just have that as a safe distance, and we don't need the sides. These are the edges, so we're gonna uncheck the output side. And I want to make sure that we have the normals properly placed here. So let's see. I want the normals to go to the vertices. Let's check. Yeah, we want these normals later on to be transferred to the shape that we ended up with. So we have this tube here. We're going to process it again with the normals node, making sure that we have proper normals for the main form. So if you see, we have the normals correct here. And then we're going to transfer the normals that we just created from the tube. So geometry to transfer attributes to for the first node, and then the reference node, the reference geometry at the left side, at the right side, I meant. So the destination, we're gonna wanna transfer the normals, let's say vertices, and put normals. So that's exactly what we wanted. And let's see if we did transfer the normals. So yes, this is what we wanted. So we went from this and we fixed the normals to always point outward this way. So we transferred the normals to the tube. It doesn't look correct because the normals, we sort of played with the normals, but this will be important for us. Next, we want to create a noise that we can control. So in the example that I gave, I actually created an attribute Bob and created a noise inside, but we can actually do that with a mountain node instead, which is a lot simpler. So with that, I'll check if it just works properly. What's important with this mountain node is we just have um the Y. Let's see. We want just or say, let's see, we just want it in the sides, not the, we want only one at the X and the Z, but have the Y. Let's see if this works. So with the mountain top, it doesn't work as intended. So let's just create the attribute well instead, as I gave you in the files. So attribute Bob, and then let's go into that attribute Bob, and we want to reference the points and create a noise out of it. So first, I want you to put in an anti-alias noise node and plug the position to position. And if you just plug this into position, it's not gonna work. What we do want to have is add the existing position of the points. Wait, I just read in the chat that some people are having trouble downloading the work files. Um, can you at least can other people type? Can you at least download the handouts, or is the handouts downloadable? Mike, are you still there? So I can't access the link. Try clicking the link. Once I click the link, it goes to the downloadables. Hmm. All right. Okay, so just chat if you're having troubles with downloadable files. So I think we'll go back to what we're doing. So attribute noise and see this part. Let's highlight this so we can see what's happening. So instead of having your position and attribute noise there, which is going to mess up everything up, we want to add the existing position, because we always want to have the existing position of whatever geometry we're referencing, and then adding this value. So basically, we're having an additive process, adding a noise on top of the existing position and then referencing it. So if you look at it here now, we see something. So we want to be able to control the frequency. So see, we want it somehow like 20. So we want to have a constant with the X, and we don't want the noise happening everywhere, just in one place. So we're gonna have a float to vector node, and this will plug this into frequency so that we can control it outside. And I'm going to add a constant node to always have the X and the Y, or the X and the Z at 1, while we will be able to control the 2 outside. So let's see if let's go out here, and then we can have the component here controllable. So it looks super junky now because the amplitude is quite high. So it would be nice if we could control the amplitude as well. So let's promote the amplitude as a parameter. Let's go up and up the level again, and then reduce the amplitude a bit. So now we see it's sort of separating a little bit better as we needed. So this is what we needed to just have some displacement along the outer portion. So if you look here again, the reason if we have a 0 value for the X and the Z, we're only having straight lines, which is okay if you have a 0 value here, but it's better to have some sort of variation still in the frequency of the X and the Z. So I'm keeping it at 1. So you see it's still sort of wavy. So after this, we are gonna use the parameters of this part as we're gonna use it a lot as a reference in the HDA. So I'll probably name this. So let's name this component. Can you rename it here? Let's rename the label as frequency. Y frequency. Frequency at, I think this is Y. So we'll see it outside here as frequency Y here in the adjuster. And then name it properly as horizontal underscore noise. And color it because this is an important node that we will be controlling later on. I think for the files that you're downloading, it's the Unreal Engine that takes long. So that will be in the later parts. If you're trying to select the downloads, which ones to download and which ones are the priority, have everything else but the engine folder last. I mean, have the engine folder last so that you can have the Houdini files right away so that you can open this and then open the base cliff, right? So as you all remember that we did sort of tweak the normals and it looks weird this way, so we have to put them back. So we're gonna add the normals node here. And right now, still looks weird, but later on we're going to fix that. So now we added can have this as a linear noise sort of network box and label it as linear noise. And then color it accordingly. And then next we have the edge damage, which sort of adds another layer of details other than this um horizontal form. So again, the reason why we added this frequency Y as a parameter, it actually controls how many layers you want. So if let's see, let's put it at 10, we have not much differentiation of the layers. If we added at 30, it sort of breaks it up horizontally even more. So later on when we're in Unreal, when we're actually baking the assets, we want some to be more a lot more linear. I mean, have a lot more linear lines than the others. So yeah, that's why we're including this. And the amplitude is how far out it goes. So it sort of becomes a little bit more freaky once you go up the scale. So let's keep it at that. We can have it a little bit lower. So let's try the edge damage node. It's a labs node. If you don't have labs, please do go ahead to your Houdini launcher and make sure that you have in labs packages installed in whatever version you have. So let's highlight edge damage and see what it does. So right now it also does the process of VDPing things for you. But for me, I want this to be a little bit bigger because it's quite intricate. So for the purpose of performance, we're keeping things a little bit lower, the ge geometry count or the point count a little bit on the lower side. But if you're doing this just for the rendering, you can have it as high as you want, just not too many millions, because we do have nanite anyway. But for performance, I'll keep it at probably 150,000, 250,000 polygons. So after the edge damage, I just want to have a good measure to have delete small parts, as always, to clean things up. I'm going to tweak the noise, I mean the edge damage so that you can actually see it a little bit better. So probably the height to 0.4, resolution to 1, and then the element size to 2 to have it. The element size, I think, is the noise of the rocks itself or the edge damage. So let's just wait for it to process. So roughness at 1. And then element size at maybe 0.2. So we see if you can see the damage a little bit more. Actually, I'm gonna keep the voxel size at 0.1 because we can a little bit more resolution there. So if you see, some parts we have the horizontal iteration, some parts we have the broken edges. So we're actually getting nearer to the form that we want. So again, we can adjust the frequency here. So I'm gonna keep it at 20 because that's the one that has more definition. Let's see what it does from 30 to 20, but you can play around as you wish. You can also play around with the height if you don't want it too washed up like this. You can still have it at like the higher rock formation that we created initially. So let's just let this bake or cook there. So you have a little bit at 20, you have a little bit more definition on the horizontal lines. And then I would add a remesh stage for optimization. So because we don't have the units here displaying the polygon count, I'm gonna press D for display and then go to geometry or guides. And then we need this geometry information from off to always on so that we actually see the primitive count or the point count. In most cases, this 300,000 would be good enough, but uh, we can have this remesh. Uh, uh, I'm just going to add the target size to be 0.02. So let's see what it does. So it triangulates it. I think this is better to have it triangulated anyway, not to have it, you don't need to have it too little, but this extra step, it doesn't really reduce the detail as much as you'd expect, but it does minimize the point count a lot. And what's important with this is that Unreal Engine will triangulate your mesh anyway. Um, so it would be faster to triangulate it here in the remesh in Houdini rather than having to wait for Unreal Engine and probably having uh messed up normals later on. So we can have let's try it at 0.15. Yeah, so we have it a little bit more detailed at 0.15. We have like a sort of, I think, double the point count. We think we can have that. So if you see here, there are a lot of parts that are bridging. So this bridging geometry in a conventional 3D art pipeline, this would be difficult to unwrap. You're gonna have to select it. But since we're using a procedural approach, this is gonna be okay. It's quite automated anyway. So um I'm gonna add a soften normals node just to make sure because we don't have sharp geometry anyway. So a good measure would be adding a soften normals node. So if you see some are kind of sharp here, soften normals node just makes everything smooth because that's what the rocks are gonna be smooth anyway. And then we're going to process the rock into its different vertex colors before we add the next layer, which is the topper and the icicle. So let's finish this first. Add this as I think we can move it here. This one is the challenge. And then lastly will be the UV preparation. So let's start with an auto UV node, Labs auto UV. And to be able to see the UV islands, let's just wait for this to bake. So there is a sort of a UV, but we want to sort of tweak it to how Unreal Engine will look at it later. So to see the UV, press Control 4 so that you see all the islands. And then let's have this set view to UV viewport. One of them, just pick one. Yeah, 01_models is where everything is, but you can sort I think include everything but the engine folder. It's the engine folder that actually is 9 gigabytes. So yeah, Walter, you can I think go with the Houdini part, which you can exclude the Unreal Engine folder first, which is the engine. So Auto UV node basically lays everything out like this. And then what we want to do is, because when we change forms, this rock can be a lot bigger, but then when it gets bigger, it will still pack it into a square like this, and we don't want that because you have varying scales of the UV texture, so we want to have a uniform scale all throughout. So I'm gonna add the UV layout node to unify it. So let's plug this in. So we're going to tweak this a little bit and to have the packing from a scale of maximum to fixed. So hold on. So we're gonna have it at fixed scale of 4. We're just setting a number I set this number because I'm looking at the UV tiling, which are these letters, and seeing which is probably a good scale to start with. And if you see this tile from A16 to I think this is P, so no, another number 15 or 16. This is the entire UV tile. It's showing the entire UV tile. So how many times do you want the UV tile to be sort of going around your mesh? So the settings for this would be, let's see if there are any still. Tile grid. So we went from rectangles to, because rectangles just goes a long way. And if you go UDIMs, it's like treating things as like separate separate UV tiles. So you want this better, so it'll pack better. So it's Unreal Engine will read this as something, as your geometry will be on top of one another. But what's important with this node is we set the scale of your entire mesh and the polygons with in relationship to the UV itself, so that you don't have some parts of your mesh displaying the textures really small and some parts of your mesh displaying it really big. So we're just unifying it at this stage, and that's what's important. It doesn't have to be very well packed. This is how it should look like. And then next, we're gonna add a curvature node. So right off the bat, let's bring this back to control one to just have the perspective viewport. So with this node, you should see if there's sort of proper separation between the colors. So there's no blue, but it will be represented in black. But I want to add I want to add a good measure just to ensure that there's separation between these three materials, because once you bring it to Unreal, any of those vertices that don't have an assigned color, there's just a possibility for it to guess. So I didn't include this in the files I shared, but I'm going to add a, a point swap node to sort of make sure that these black pixels or these black vertices have color still in them. So let's see. So we want to reference the color, existing color from the curvature node, so we're gonna bind. So the bind node actually references a parameter or an attribute outside of this, or whatever the mesh is reading. So let's put CD here. And CD, the color node, is a vector, so it has three values. And we want to sort of isolate those three values. So let's add the vector to float node so that we can gain control over each of those XYZ or RGB values. And then float to vector. So we're okay with the red. So since it's RGB, it's XYZ as well. So R, G, and B. What we do have is the red and the green. So it's the first and second value. So we're just going to plug them in to check if that works properly. Bind export. And then we're going to bring out the CD. And so if you think about it, um, you're going to have pixels that have black. So you're going to minus all of the values of the vertices with what are existing with the red and green already. So let's try. So let's maybe add a constant 1. So everything is 1 minus, let's subtract. So we're subtracting 1 minus the red and the green. So let's see if that works properly. And then, so let's put this to 1. So when we put 1, we're treating, so if you look at the RGB colors and we separate them, separate the RG and B channels, you'll be left with a 0 to 1 scale or a white to black scale if you look at your entire model. So if you look at the red channel, the red parts will be white and the non-red parts will be white or black, and the same with the green and the same with the blue. So one makes sure that everything starts at white, and we're adding black to those that are green and those that are red to come up with the blue channel. So this is just the one other measure to ensure that we're having the vertex colors properly read on our mesh. So beside this, let's do channel. And then lastly, an Unreal Material node. Later we're gonna put in the string to this when we open the Unreal Engine and reference the material. We're gonna input it here, but right now, let's leave it as is and add the merge node here. So this is where everything will be funneled in. Let's, Let's add a network box to this area and name it as post product. Okay. So you have the merge node at the end. Okay, next we're gonna go with, let's look at our schedule. So time check, we have, like, I think we're halfway to the procedural clip. Next will be the topper, the sort of topper element, because when you um let's try to see. Let's try to see where it plays in a reference of a cliff. No. Hmm. Could you uh can you send over the exact node that is giving the error so that we can see? And then maybe, I'm not sure if you can actually add a screenshot there. Can you just post it so that it can help everyone as well? Okay, I'll get back. So I'm going to look for a reference online. Then I'm gonna open up PureRef again. Okay, so with PureRef, I put like just a quick Google image search just to show. Actually, I'll flash this in. I'm gonna exit this. If we look at the cliff, naturally the rock formations will form and there will be sort of a dust or a sand sedimentation on top of and we want to sort of mimic that, how the sand deposits on the rock formation. Later on, it will help us blend in the rock itself with the landscape so it doesn't look too clean and unrealistic. So let's close this. Okay, let me just open the chat to make sure. Material. So we'll go on to the topper node and I'm just gonna show an overview of how it looks like, or I think I did already. Showed how the sedimentation looks like. So we're going to want to take it from the node where before everything is post-processed, because if you take it here after the post-processing, it will have to calculate that again and again to which is this auto UV before adding the whole set of nodes. So let's have a mask by feature node and take it from the soften normals. So what this does is we're going to have a directional mask or everything that's at the one direction, one of the Y, so probably at the top version. just can't see it here. And then I'm gonna uncheck cast shadows. And let's see, we're going to use this because it's gonna output as a mask. And then we're going to scatter. We're just going to scatter on those points that it's actually referring to. So right now it's scattering around the whole rock. But do you want to use a density attribute which which we derive from this mask by feature node. So from this mask by feature, we created a mask and then we scattered along that mask. And for me, I want to force total count a lot more at probably 5,000. What we're going to do, or let's make it a density instead. Whoops, too many zeros. So we get 5,000. Yeah, let's have it at that. So let's check the mask by feature. We want the deposits to be reduced. So we're gonna reduce the maximum angle to probably like 85. Because we want, in reality, those that are at 90 degrees they actually are starting to fall off. So you wouldn't include them. So we're reducing here. If you see the the edges are getting reduced. After that, we're going to create a VDB from particles. Because we want a form out of this point cloud. And then screenshot. Let's have the voxel size at 0.02. Let's see. Point radius at 0.05 and minimum radius at 0.5. So we end up with this sort of cloud formation. I think like if you cannot share a screenshot, I think, and if we can't really go into the file to fix it, I think let's just like sort of reconstruct the entire script on a blank file. Because if we can't actually see the file, we cannot pinpoint which is the node to fix. So yeah. So right now, if you turn this into a convert VDB, it will look too huge. Let's see. It will look like sort of an ice cream cone. It look like an icing topping. So if you merge it now, this is how it'll look like. Not very appealing unless you want it that way. You can actually see the ball, the globule still. It's too huge. So what I want to do is in between this convert VDB, add a VDB shape, reshape STF, which changes. We're gonna offset it at 1 point. 1 point. Let's make it instead of we're trying to make it smaller, so we're gonna change the operation from dilate to erode. So there we're reducing the size of the VDB. And then let's see how it looks like. So we're getting a lot thinner of we're having smaller, a thinner sedimentation depositing on top of our form. So if you look at it now, it's sort of a little bit better. We may want to be able to control this parameter later on. So See if this, you can control it here or the VDB reshaped. But in this case, we're just gonna leave it as is. Probably see if we can tweak the max angle. Maybe it's by 75 or 55, reducing where the sedimentation occurs there. And if you add cast shadows, it's gonna add the self shadows if you want it to be more realistic that it only deposits, like for example, snow deposits from the sky to have the other parts avoided. But in in my case, I'll just uncheck the cast shadow so that most of the surfaces, because in reality, when the sandstorms occur, you're gonna deposit even not just from the sky directly, but from the sides as well. So this looks probably will look a little bit realistic anyway. And then because there's so much fragmentation, again, for good measure, I'm gonna add a delete small parts node. And I think that the 0.07 will be good enough so that it doesn't delete as much. And then I sort of added a delta mesh node to relax the edges a bit so that it's not too sharp. So at 10, it's too relaxed. So I'll just probably put it at 2 so that it's not too sharp. So if you look at it before, it's kind of terminations are kind of sharp. And relaxing it makes it look a little bit, you know, tucked and well put together. You can skip this if you want this, if you want it, but it for me, it's at this stage, it's just too fragmented. For me, I could add I could make the voxel size a little bit smaller. Let's see, so that we can add a little bit more detail. So let's make it 0.15 or 0.1. Oops, yeah, 0.1. I think for the Google Drive you sent, it needs access. Okay, okay, here. Still needs access. So hold on. Yeah, so let's go back to this voxel size and see if we could sort of bring it in a little bit more. Yeah, see the sedimentation. See it at maybe 3.5. It's a little bit thinner. Maybe 3.8 works fine. Yeah. So I just changed the VDB from particles voxel size from 1 to 2 and adjusted accordingly so we have just a little bit more detail. Because we're not too concerned as much with the primitive count anymore. Yeah, and turn on the delta mesh again and it smooths everything out. I just like the edges better when the delta mesh is activated. It's not too aggressive, just enough to curve out the edges. So if we stop here, we can see that the depositing is actually working pretty fine, but we still have to process it. We have to add the curvature and UVs as well. So let's do that. Start with soften normals because we know that this node doesn't use sharp normals anyway, and it's an organic form. And then a color node. Actually, skip the color node, and we can go to UV project. So this is a simpler, faster way to calculate. I decided to go with this method of UV unwrapping because once you get to this topper form, it becomes more difficult to unwrap because it's a more complex form. So I will just project it from a surface. So if you look at this, if you press enter on the UV project, it's actually showing which plane it's projecting from. So I want to rotate that to 90 degrees so that you're projecting from a plane on top, because it doesn't get more complicated than that when you look at it. It's depositing from the top, so you can lay out the UV from the top anyway. So yeah. So UV project from the top, rotate at 90 degrees at the X value. And this will be good enough so that we can move on to the next portion, which is the curvature. So let's add in a curvature node. So you might want to be able to control this later on how much of the red parts are seen. But for me, I want to make it a little bit different at the edges so that, let's see. Sometimes in the edges of the sedimentation, you can have like, instead of sand, it can be smaller rocks, or that would be up to you and how you want to treat it. But this curvature node is just there so that you have control over the differentiation of the material. So you can have like the finer materials at the green, the base material at the blue, and some sort of maybe moss or grass at the ends. It's entirely up to you. You can control the convexity, probably put it at 5 so you can see the red more. And then you can add this sort of blue channel node again as you need. See if it works. Yeah. So that has a good measure to have all of the channels used up. So it's still procedural. So if you want the green more seen here and add the blurring to the green, 5. Actually, click that one. It will adjust it accordingly anyway. So, and then, yeah, plug this in instead of the other one. And then, as usual, the Unreal material at the very end. So let's just tidy things up and with a network box here and add this as the topper. Okay. So you have two components now, the actual cliff and the sedimentation. Later on, we're gonna add an option to include or not include the sedimentation. So let's go with the icicles. So with the icicles, when this was being conceptualized, I was thinking, where do the icicles form? Isn't it that it forms from the underneath? So the very same way that we masked this from the top and had the toppers, we're gonna have some points of the the underside features have icicles. And I just wanted to add this icicles feature because it gives this sort of surreal look. But in other cases, you could just exclude it. So if we were to use this form and add icicles, sometimes it will scatter at the very ends, and so we want a more tucked in form, and that's where we add the icicles. So what we're going to do is go back all the way to this VDB area, and we are going to tuck in the form before it got processed. So we are going to offset it at, we're going to erode it, probably maybe 5, to have it smaller that way, and we're going to use this as as an object where we're going to scatter the icicles. So VDB reshape, then convert VDB to polygons, from volume to polygons, and then same mask by feature here. We're going to have it again. We don't see it yet, but we can. Actually, it's not as much colored. It's actually supposed to be colored, but can't have it as a CD. So you see it. So if you want to visualize it, just have it on CD rather than mask. But so is on white now at the top. So white is where the icicles are gonna appear, but we want it to be at the bottom. So we're gonna turn this direction from 1 to -1. So you see most of the parts at the bottom are having that. If you turn off cast shadows, it will have everything at the bottom, no matter what. But let's turn in cast shadows anyway, because we want only those that are sort of seen by the ground. Let's see how it works that way. So I will have one blurring iteration. Reduce the max angle. I will reduce the max angle from 90 to probably 55. So you don't have the very ends having icicles, just the very middle. So let's have it at that. So only icicles that are like almost horizontal. Only areas that are almost horizontal will have those icicles. And then I'm going to add the scatter and align to add points. So from CD, we're going to change it to CD to from CD to mask so that we can reference it here in scatter and align. And that we're gonna check the point cloud method from by size to number of points, and then add the density attribute, which is mask, which is specified earlier. So if you see it here, we have points at the bottom, which are if you have the icicles falling from the bottom, you won't see it anyway. So we're going to have sort of a limiter that takes care of all those points, which groups all those points at the bottom, and we're going to delete them. So I think one way to go about this, have a bounds. So we're gonna have a bound to check the entire object, and we can transform it and reduce the scale of the Y, and then align it to the very top. So none here, and then at the max, I think the max, yeah. So max to same aligns to the very top. So if you reduce it, it will reduce from the top after the match size. So we're going to group that. So if it's at 57, it's probably at 57% of the entire height. We can actually have it that way, or since our icicles aren't by scale, we can just have a box as a limiter and say that box, or wait, by the time we can match it by min, because we just want to group the bottom part. So instead of that, we can have a box because we know that the icicles uh aren't they're not smaller if the rocks are smaller, they're just like a fixed size relative to the entire cliff. So we can have a box, and let's just have an arbitrary scale that's bigger than everything. We know that will be bigger, so we won't anyway, we won't have any cliff that's this size. And then we have a match size and have it align to the horizontal axis by having it min and grouping the points that we want to delete. Points from group by points and keep by bounding regions and use a bounding object. So by adjusting this section, we will be determining later on when we create the icicles what is the threshold in which the icicles form. So for good measure again, let's change the node of the input, change the node shape, and blast. Let's blast group 5. So we're only we only have these points at the top, so you don't have icicles forming at the very bottom. So and then we want before we scatter. So so let's just keep this section as is first, and then start creating the actual form of the stalactite. So let's have a tube. And change the shape and color again. So let's look at this tube, and I want it to be sort of elongated. So 2.5, have the radius at probably 0.06 and 0. So you have it pointed that way. So we want to have it a little bit more detailed so we can displace along its horizontal axis. So let's have the rows at 30 and the columns at 100. So I see it's a little bit packed that way. And then let's have a UV project node to have the UV projection early on while it doesn't take too much to calculate yet. And what this does, let's check it, is it is the graphic cylindrical. So let's have it at cylindrical so that can unwrap it this way and have the textures aligned this way later on. And when we displace it, it won't be difficult to calculate. So let's go back to this. Actually, let's change the angle so that the UV layout. Let's change these scales so that the UV layout will be better scaled. So let's reduce until it becomes relatively squared out. Or either that or it's either that or I think that's the best method to reduce the Y until it becomes square. We usually have do this measure to ensure that the textures line up properly. So I always show the UV projection. So let's reduce this until it's relatively square. I think we're good with 0.45. And then add the mountain node now to get the form of the actual, oops, form of the actual stalactite. So right now, it doesn't look too good, but we are going to fix the noise value or we're going to have it, we're going to tweak this as from having it zero centered to positive. So adds, it only adds value and doesn't subtract so that the mesh doesn't eat in on itself. Let's have this value really low, probably 0.006. Let's have it high first. And let's tweak the element size to something more a lot manageable at 0.13. So you see right here, the noise is actually displacing properly, but I want it a lot smaller. So let's have it small at 0.06. And then if you remember, we created the tube this way to have it pointy at the end. We can have a mask to exclude the bottom, but for me, I will just offset it until I find a portion that doesn't have displacement here at the bottom. I just offset it to 1.76 so that it's easier that way rather than just creating a mask at the bottom that excludes this. So I'll keep this. I think I'm good with this form. And then I'll add a transform node to make it smaller as needed. Probably at this stage, this small. And then to match size it so that when we scatter the icicles, they will scatter from the very top. So let's see. So we're gonna match size to max. So it will align when you scatter, it will take from the zero, because it will always scatter at zero. So we want it to be aligned that way. So match size, let's group this. We already created the icicle. And then let's copy the points and see. So at the left side will be the geometry to copy and the right to point cloud. So let's see. So right now, if we merge this here, it won't look as well. It won't look as good because it's actually pointing all to the top. So we're going to add several attributes to the points to be able to fix that. So first, I'm going to add an attribute randomize to the P scale because the P scale will control the size when you copy. So let's add P scale to the attribute name. So right now, as you see it, it's playing from 0 to 1, but we don't want a 0 value, so we can start by 0.1. And then we're going to add an attribute randomize. We're going another attribute randomize to fix the orient scale. So the orient is another parameter that rotates it along its axis. And we want to sort of fix that to orient downwards because right now, what it is doing is it's referencing the orientation or the normals and the normals of whatever geometry is here, and it's transferring it to the points. So in that case, everything is curved here. What you do want is to have it semi-absolute to sort of point downwards. So we're going to add another attribute randomize. To not color, but the orientation. So orient, another attribute that is native to Houdini. So right now, if you change orient, it will point it to a certain direction that we have values here for. So I want orient is actually a matrix, not a vector. So a matrix is, I think, four values because it's four because one usually you have three values x, y, and z, but the fourth value refers to the axis. So I had um I changed it from uniform to direction and orientation, and you can have a cone angle. Right now it's randomizing the orientation because we had direction and orientation. It reads it as 4 dimensions. It knows that you're actually playing with direction, and we want to sort of funnel that downward into a cone. So let's check the cone angle here. Let's make it around 2 because the higher the value, the more it differentiates. So now let's see. It's actually pointing upward. So let's see. Let's see what we did different here. So 0 and then 1. So if you change the value to 1 here, it will actually point the direction downward. If you want to change how it plays out like this, can add the cone angle, but it's not quite realistic. So let's see how it blends in with everything. So right now, this is what I meant by having some of the icicles go below. So either we can, let's network box this first. We can actually transform the box. So something bigger. All right, the exclusion zone, where we can actually transform the exclusion zone to be a little bit higher, or we can reduce the size of the stalactites or the icicles. So in that case, we'll do maybe both. Let's have this higher. There. A little bit higher so that you still have some. So let's have this as other points. And do not forget to add first let's add curvature to the icicle itself. So we still add variation. So let's see how this goes about. I'll turn off the grid so that we see it better. And then turn off the UVs so that it reflects a little bit better. I might remesh this to have better resolution. So might have this. More rows than that. 360 to add resolution or 80. Yeah, that's a little bit better. And then remesh it. That's too big. So 0.1. So we'll go from 8,000 because we will be scattering this, so it must be a little bit more manageable. So I think I'm good with that size. But again, when we see this, let's make it a little bit smaller there so we can have differentiation still. Can still be smaller. The let's have this a lot more. Let's have this way bigger. So we have a lot more detail going on here. Maybe I want to tweak this a little bit more to have more amplitude. Oops, I added more displacement. So this is the step I'm adding. So we measure it again. I think this is now too small. Yeah, I think this is more manageable at 7,000. And see, we'll see if the red color is reading. So in this case, it's not as much. So I'll increase the multiplier to about, I think, 10 or 20 to see some sort of differentiation there, or 40. And then do the same for the green so you see it more there. So we have a little bit more detail of a stack type. With the example that I sent, it wasn't too detailed and we didn't have this step. But we can afford to have this step anyway because we will be packing it to an instance. So we will sort of optimize it. So we can have it a little bit more detailed. There. 20. I think we're good. And then have this blue channel again, which I didn't do. I think it's better to have this. I can make sure to pack and instance it. And then when we're copying to points, here we go. Just have to make sure that it is rotating. So let's see. Okay, line. Let's see if this changes it. No. Let's try to add another randomize if it does change the rotation a bit. Hmm. Let's see if we add a scatter and align node here, if it will change anything. Or no. What? Later on, I think we can add another node that rotates it, but I think the icicle so that it has some sort of variation. Let's see, try to tweak it this way. So as it is here, we don't have the orient, it points upward. So we can align it to Y. If we align it to Y, and then we have rotation at around normal, we can have a minimum and add it to 360. I think this way we don't need the orient. So right now, with just the scatter align, we can change it that way. So yeah, maybe we don't need the orient attribute and just have the scatter align. And I think some of the icicles are kind of too small, so let's add the minimum value to maybe 3. And then let's see it add in here. Okay. Going quite nicely. Remember at this portion to add on Unreal material that we will later on add a string to. Okay. So we finished the 3 components now. Let's see. I think instead of or we'll have the break after. We can have it now. I think we're right at the middle. So we'll have the break now instead of having it right after the finishing the cliff portion, because we still will have to create an HDA out of this. So you're gonna have to pack this for Unreal initially in our schedule. So I think we'll have it now instead of later. Yeah. So can we have a 10-minute break, Mike? I think we can have a break anyhow. I'll just pause sharing here and mute myself, and we'll resume in 10 minutes. We'll be back in 10 minutes. All right. So let's resume. So in the in the file I shared with you guys, there is a network box at the side that I didn't include, and it says grasp. We can actually still populate this section with grass, but I thought in the end, when I was sort of putting the scene together, that it was sort of a desert environment that really didn't have much vegetation there anyway. But you can scatter on top of this sort of topper by the same method that you added the icicles, and just remember to pack an instance so that later you can go to Unreal and change the instance to probably a Quixel mesh or something as you wish. So you can include that later or not, up to you. But what we will do with this file now is what is happening here. We will pack this into an HDA and see if which parameters we will include in the HDA to be able to control it later on in Unreal. So to do that, by selecting this, I'm going to assets and new digital asset from selection. Let's see. And as it is now, it creates this digital asset and it's recomputing everything. Let's just wait for it to cook. So you guys can just ask questions along the way. I'll see it anyway if you need. So we finished the asset creation. Now we're actually packaging it already, so you can ask the questions accordingly. To let's say, I think I chose the wrong method. Let's undo that. Not just letting it cook. Or rather, let me accept that. Let's redo that. Redo. Let's see. Okay, go to merge again, and then select. Still cooking again. Again, we're just waiting for it to cook. Takes quite a while. And then create a new digital asset from selection. repeat that. Cooking again. So I think we allocated a lot more time for this cliff because um we will be reusing the concepts anyway later, so the landscape will be a little bit faster as well as the architecture. So yeah. So wait for this to book. Okay, let's create it and modify it. Why does it keep on cooking? Actually, it's saved to, I forgot to change the save to library. So you must delete that because it might mess up the next I'll just go ahead and delete that. But we have to change it first. Actually, I have to save this first. I forgot to save this. So I'll exit it so that it doesn't cook and right click, type properties to edit this. I'll go to this location, make sure I'll clean that up first. It shouldn't save as an OTL. So I'll delete that and pick hip because that's the location of the save file. Remember, that should always be the hierarchy of your files, your actual Houdini model, and then inside you will have the HDA exports, textures, and all of the smaller files that are referenced within. So that when you transfer the entire package, you just select the folder on top of it and then send it to someone else so that they can open. So you want to be saving it in model hip models and then HDA. Hip is where the actual Houdini file is. Then go to models, HDA, and here are some of the HDAs I saved earlier. I'm gonna create another proc generator. Let's name it proc generator underscore 2 because I created one earlier already. 2 and make sure the path is relative to current directory so that when you transfer it, um, other people will be able to read it and change the label to rock underscore 02 and then remove the maximum inputs. Let's make it 0 and then apply and accept. Cannot access this. See, I think we have to undelete that. I'm not sure. Or we should have just changed the directory. Now it's at the very start when you created the asset. So now it's looking for that definition. So either create it again or just retrieve this. Whatever is missing, we just deleted now. See, hold on. to restore that and go back. Okay, I'll retry now. I restored it and yeah, just have to change now the name and the let's wait for it to cook. Okay. So let's rename this to rock underscore generator underscore 02 and check if you actually have the HDA saved. So let's let this cook again first before we ensure that we save it. I'll probably unclick auto update so it doesn't cook every time I save it. After this, okay, I'll change auto update to manual. And then I'll make sure that I'm able to export this one. Let's see. So I have to click on this HDA and go to assets and save asset. Let's check if it's there properly. Generator. Okay. Let me just ensure that it's saving. So just checking if everything is outputs there. So save asset. And you should see it in the HDA folder where you had it saved. Check the name. Should be there, yeah. Okay. I'm not seeing it, just that hold on. Okay. So it's not saving. Let's just let me just create another version of this. So I'll turn off again auto update. If your HDA doesn't work, what I usually try to do is cut and paste the entire thing. Remove uh the HDA we created and paste it outside, but it needs to be inside the geometry. And then I'm going to sort of create a package again. Let's try. So asset label is underscore generator underscore 0. Let's make it 3 now. And then save it to hip, $hip to models to HDA. And then we'll ensure that the file name is correct. Underscore. It is not. Yep. Yeah, let's have it installed there anyway. So create. Maximum inputs again at 0, apply and accept. And then let's save the asset. And check if it works. Okay, now. Yep, it did export it. Let's just check again. Set 0 rock 03, yeah, correct. It exported properly. Let's delete the previous one. Let's just make sure this cooks first. Turn on auto update again. Cook habit cook. Yeah, let's just wait for it. Okay, now what we want to do is we want to add inputs or parameters here that we can control in Unreal. So this is the parameter. These are the parameters of the HD itself. And if you configure this properly, it will show up in Unreal. So what we want to do is create controls that we think we'll need. So if you look at this rock, what are the parameters that we think we can control? If you remember earlier, we had the height deduction wherein we selected part of the rock, the cliff itself, and or the Voronoi, in which to keep and which not to keep. So let's have a folder for your main controls, and let's name it as main, and then controls. That main space controls. So this is the name here on top is how Houdini reads it, but this is the one that's important as you read it, the label itself. So instead of having it as tabs, I wanted to show up in Unreal as like everything's just open. So let's just make it from tabs to simple. And then we just have to we just have to pick we just have to go back to that area wherein we were deciding on how to size it here at the transform. So this scale we'll now use as a parameter. Oops, parameter. Oh, or we're going to drag in a float because this is a float at 0.5. It's a float, and let's say it's the vertical inclusion. See, okay. So um, let's copy it. First, let's make it a range from 0 to 1. It has to be locked from 0 to 1 because there's nothing beyond 1. Let's lock this at maybe 0.1 so that it doesn't go to 0 and max out. So it will show up as a slider in Unreal, but when you slide it, it will be limited to 0.1 to 1. So let's drag this to the scale. I think whatever happened here. I don't think that's how you do it. Delete parameter and copy parameter and then paste it here. Paste relative references. Okay. Or we can do it the other way around by putting it as 0.5 and dragging this here. See. Let me just check how it was done in the past file. Here. Right, let's do it again. Okay, I have to highlight it and drag it. So highlight the value and drag it here. So again, let's lock it from 0 to 1 or 0.1 to 1. And then should be, yes, a float because there are decimals there. And let's label it as limits instead, vertical limits. So now we're good with this vertical. And then if you remember earlier, we could actually control the seed of this global seed of the scatter. So again, highlight it and then bring it to the main folder. So global seed. And then let's change it just so that we can understand it. Rock configuration seed. Okay. RC seed. Okay. Let's see if those two will be reflected first before we populate the parameters. Let's see if it will be read in Unreal. So let's apply and accept that. That's what's happening here. Just using another reference that I deleted again. Hold on. Okay, I'll retry that. Okay, it's working now. Apply and accept. So I just have to check if it will update again. So 208, that's the right time for me. It did export it. Now I can actually open Unreal now and see if it works. So I prepared the project that I sent to you guys earlier. I'll be opening that. And that's where we'll start doing the trial and error for the Unreal map. Okay. So I'll just be opening up this Unreal. Remember, guys, you should use Unreal 5.3, and remember, before we do anything with the HDAs, remember that you must have this Houdini Engine plugin and make sure that Unreal Engine plugin 20.0.625 is there. just go over this. And if it doesn't work, you should have on startup, you should have this Unreal Engine, Houdini engine open tab or this tab right here on top available. If not, you had some uh problems in installation, I think. Let's check how it is. So make sure that the installation directory is here. So program files, side effects, software Houdini engine, Unreal 20. So it must be in the side effects folder, and it also must be in your Unreal Engine plugins folder. So let me just do a quick search just in case any of you guys encounter errors. So the plugin must also be in this location. I'll send it over in the files. It must be in the plugins and runtime of Unreal Engine. So in case this Houdini Engine tab does not pop up, you have to check if the Houdini Engine folder or the version in itself is here. So in this case, the Google search I included showed a UE 5.2, but in your case, if you're using 5.3, must be 5.3. So you have to make sure that the Houdini engine you have is working for Unreal 5.3, not any other version, and it's corresponding to whatever Houdini version you're using. So um, with this Houdini engine for Unreal 5.3, it's pretty smooth now. So I'll just go to the third person map where I make changes. If you're creating um uh a new um engine file, you have to go to library and uh launch the version you installed, 5.3, launch it, and then create a project, and it has to be a third person template project. That's it. That's just how what you have to pick out. So once you create a new project that's a third person shooter, you'll be led to this map, and this is where we will start. So in this case, I already had the previous HDA here, but I want to show you the process of bringing the um HDA we just created together here in this tester. So open up the HDA folder on where it's saved, in my case here. And then if Houdini Engine is run here, I created a folder for this tutorial. It says DM underscore 24 underscore 1. And I have a folder here for all the HDAs I'm importing. So now it's as simple as dragging and dropping from your folders the HDA file onto the content browser. This content browser is as the way to bring it up is control space and then drag it up here, drag it in here. So now we have this rock generator HDA. Let's see if it works by just dragging in here. So right now I think it's loading, but it says the Houdini engine has not started. What I'll do is I'll create a session. Let's see if there are some errors here. So let's try to create a Houdini session here. So let's see if this is working. I'll go to Houdini engine, session sync, done. I'll try other methods like restart, probably restart. It says failed. Okay. I'll just try to troubleshoot this. So in my case, it's only this HDA that's not working, the one we just created. I think it's because we have files on top of files. That's why it's not loading. But I'll try to restart the engine, maybe to see if it probably works. I'll save these. I'll restart everything. I'll close out uh the other instances of the engine. I'll save this one. Close. So launch Houdini again. And then launch the Unreal. Let's see. So let's go back to the third person map and go to here. Wait for it to load. Okay, now it says with a restart, it started connecting now. So let's wait for it. It was somewhere here. Let's wait for it to cook. So I'll just see where. So we have it here. It's somewhere here. Let's just wait for it. No, it doesn't have the icon anymore, which is what you need. Here, right here, it updates you on which processes it's going through. So great, right now it exported everything. It brought in everything as intended, and let's see if our the HTA parameters we included are here. So since we added here, it's as a simple, not tabbed, it's shown right here right away. So we had the folder which we created, and then the vertical limits and rock configuration seed. So if we change this probably to 0.6, it's gonna cook something higher probably. So let's see if that works. It is taking quite a while compared to this previous iteration because this is a little bit more detailed than the one I created beforehand. It has a lot more poly, so it takes a little bit more time. Okay, yes, it did act as we needed. So this this really just displays that you can actually uh control things and the parameters that So, basically creating a tool in Houdini and giving that tool to other artists and letting them play with it in or configure it in Unreal, depending on how the intent is. So the parameters work. So let's just open it again because we closed it earlier. So let's check out the file that we created. And then we'll come before adding the material, before creating the material, we'll go ahead and finish off the remaining parameters that need to be included. Okay, so again, I'm gonna maximize it, enlarge it, and then have the parameters at the side, and then right click on the HDA on top and type properties and go to the parameters tab. And for me, I remember that we wanted to have an option to include or not include the icicles or the topper. So these are the sections for it. And the way to do that is to have let's say a switch node. Okay. And then we want to switch from actually referencing something or to referencing nothing. So if you want to reference nothing, just add a null node. Let's change the color of this to red. So the way you're gonna have a toggle for it to include that topper or not, we're gonna have it at the very top of where we calculate the topper, so it doesn't have to calculate it extra if we decide not to include it. So copy this again and then bring it here to main. And then from it right now it's an integer. I want to make it a button instead. So button will switch from 1 to 0 to 1. 0, wait, let's make it a checkbox or a toggle. Yes, toggle. Toggle to, if you check it, it's gonna create it's gonna have it 0 at 0. If not, it'll have it to 1. So let's change the label to include topper. And do the same for let's do the same for the icicles. Copy this here. So once it's on check, it includes it. Once it's unchecked, it chooses the null instead. So do this again. Drag it to main, change this to a toggle, change the name, include icicle. And then let's hit apply and accept. It again recalculates. And we have to wait. So after this, once we finish the parameters, we can now create the materials and how the differentiation of the different blends of the vertex colors. So it's saved the definition. You can just wait for that to cook and make sure now once we save the HDA again, we have to always, once we update it, go to the HDA itself and right click to re-import. So let's just wait for this to cook. Once it's cooked, we can now let Unreal cook through Houdini. So we re-imported this and then now go to the HDA on the screen and rebuild it. See how it will update. So since we resaved it, it's just rebuilding itself. We added the parameter to include or to not include the toppers and the icicle. So let's see how that works out. So I think checkmark includes, I think we just have to switch it. Let's see if it actually works. So when we removed when we added the check mark for the topper, it removed it. And check mark for the icicle, it also removed the icicle. So I think we just need to let's put this on manual. Just need to switch the two. We just have to drag this up. Switch the two inputs so that when the check mark is on, it actually includes it, and when it's off, it doesn't include it. So let's include that again. Okay, now it's there. We'll just save it again later on, but in the meantime, we can create the material. So let's make sure that the icicles are here. Okay. So I have another folder here where all the materials are created, and I created one beforehand, but let's create one alongside each other anyway. So I'm gonna create a parent material that we will be using for most of our blend materials. So right click, add the material, and change the name from m_blend material blend math. Since we already have one existing, I'll create a duplicate at number 02, another iteration of it. So let's have it here. So because we're blending materials, we can't just funnel in one base color. We are going to define different different materials and then funnel them as a whole with all these attributes included, then funnel them into the output. So we must check here, use material attributes, because we're going to have the attributes blended at the earlier stage. So So first, let's start with the whatever textures you can get. So let's start with basically quick cell textures. In that case, right click and then add quick cell content. This opens up um the bridge wherein you can get different textures. In my case, I already pre-downloaded some. So if I go to the local tab, I have different surfaces already prepared. What I suggest um for this session would be to go to uh this icon in Bridge and go to collections and environment and go to the natural section and then canyons of Utah. This section more or less has much of what we need because we have sort of a desert environment that's why not canyons of Utah. So for the base cliff material, I wanted something that wasn't too busy in a sense so that you can you didn't notice as much how it tiled and you could see the material more. So I went with dry sand and some of the more basic materials, the rocky ground, but not too busy. And then I want one base material that's kind of plain. And then for the edges, I'm gonna get something more jagged, like the canyon rocky ground to have detail. And then for the sediment, I had the sand layer. So dry sand. So just go to this Canyons of Utah, probably first for starters, download three sort of different surfaces, but they're more or less the same color. But we can control the color anyway later on, but it's good to start with more or less the same color and then just have differentiation in Unreal itself. So once you press download, um, and then you're going to be met with the screen in the local area, and then there's this button export, and it will export it to your content shelf, content browser. Done. It will come out as here in the, let's see, mega scans and then surfaces. So I have this. So let's start with something basic. So I have a lot of materials loaded here already. Let's start with probably this rough sandstone rock. And as you see, the way Unreal sends it over here is you have one base color, you have one normal, and then you have this yellow sort of texture. What this is it's an occlusion roughness and metallic map that is compacted or compressed into one. So because occlusion, roughness, and metallic, they each are grayscale maps or black and white. You can have them in different channels, red, green, and blue, and then just separate them later on because they're more efficient that way. So I'll show you what happens. So first, um, drag in the textures here. So there's base color, normal, and roughness metallic. So you have to have a coordinate. To be able to control UV coordinates or the tiling, you must have a texture coordinate node at the back that plugs in here. But to be able to control it, you have to turn it into a parameter. So texture coordinate is a two vector or two floats, not three. So you have to multiply it, drag it out, and put a multiply node, and then append because that's how you add two values together. Append vector, or append vector. So there's two values. and we want a constant. So I held one, so hold one and then click anywhere to bring up a one or a float. So either a float or integer. So I want the default value to be one because we're gonna title it by one first, and then have one at the x or the u and the v value, x and y, because that's how the texture coordinates are built, x and then y, and then multiply it, and then have them funnel into all of these textures. Next, so first we want to have a make materials attribute. So keep in mind, we're making the first material in 3, okay? Make material attributes, and then have the base color here, and then the normals, and then RGB. R is for ambient occlusion, green is for roughness, and then B is for metallic. So it's always it's called an ORM map. If you're forgetting, it says ORD, sometimes ARM or ambient occlusion roughness metallic. So it's always in that sequence. So we are creating these attributes and then funneling it here. So let's see how it goes. So we have to have several of these sections and then blending them to come up with something that we funnel in here. So to be more um, efficient with time, we have to sort of fast forward it a bit in this section. So just I'll open up the material I already created. So what is important, so if you look at the one that we've done, we've created this section, but it's lacking some things. So if you remember, we had the base color, normal, and then occlusion roughness metallic. You have to have this texture and create a parameter out of it. So the we create a parameter out of it so that when we make instances, or let's try to make an instance out of this one first before we move on. Let's see the concept of instancing. So I'll go to the materials and then I'll save this first. And then I'll open this, or I'll right click and then create the material instance, mi underscore, let's say, let's call it test blend underscore 01. And if you see, there are no parameters to control here. What we need to do is expose some of their parameters so that when we create duplicates or instances, we can create variation using those parameters. So we need to be able to change in the uh, material instance the texture that we're including. So in that case, we have to right click each and one of these, convert to parameter. So you need the base color texture to be a parameter, so it's going to be BC. Let's make this a material 1, BC1, and then group it as the red material. Red, because that's the first RGB. So red material. Remember grouping it. If you group it, we're gonna have multiple materials and they must be grouped together so that to work efficiently. So BC1, no, normal for 1, and then create a parameter again here. ORM1. Remember to select them and then group them into red mat. And then you have to have this tiling as a parameter as well, convert it to parameter, and then let's say tiling 1. And then this is under the red mat group. So let's save it and see how it reflects. So now, if you see here, all of all of the parameters we just created are here. So if we need to, for example, we have another texture and we're gonna change the base color normal and metallic, or occlusion roughness metallic. We just open our content browser and then press this button, use asset from selected content browser, and then click another occlusion roughness metallic. Then we can also control the tiling because we added the tiling parameter. Let's say from 1, let's turn it into 2. You see it's getting a little bit smaller. And then from 2 to 5, we can control how it tiles per texture. So that's basically the concept of one material to funnel here. Now I want to show how we blend them. So let's add, I forgot to discuss adding a tint parameter. So I multiply this base color, multiply with a tint, or hold three, and then click anywhere to come up with a vector. So if you have a vector, it will display as a color. Make that a parameter as well. So what this does is you can multiply the base color with any tint, let's say pink, and you can turn it pink if you want. So this is just if you have different materials and you're trying to blend them together. So you add tint so that you have a unifying hue. So once we add this tint as a parameter and fix everything, and you have this make materials attribute, we want to be able to start blending. Now, because we started blending, because we included the RGB, so there is a vertex color. We want to include a vertex color node. So right click vertex color at the bottom. So this vertex color, either you can get directly the red node or the green node. And then the way you do it is you blend the two materials. So you funnel from the make material attributes. For example, you already had 3. So what we're gonna do is we're gonna blend first the R and G, and what's left, what's the combination of the R and G, we're gonna blend it to the B. So we're gonna blend the red with the green as the base and top material and have the alpha, the red channel. So you plug the red all the way to the alpha so you can differentiate actually which is red and which is green. And then from the output of that blend, we blend again the blue with what we just blended and have the alpha as a green. So the reason why I'm fast forwarding this is because it takes quite a while to create the parameters and add this, but I have to explain this so that we can create the blend material. So, and it is shared for you. And right now, as we have it, we have one material. I think we can after you're able to put things together, you can have it just as intended with 3 materials. So if you check the Unreal Engine file I gave you, just check this node. There's not a lot of gap between what we just created and this. So let's try to reference this. So now we can actually just change this. We will reference this mi_test blend to uh the rock cliff we just created. But because we've already finished I've already finished a blend material earlier, I just have to change the parent from what we created, m_material blend mat02, to the one that I created. And here you see the reason why we had to move forward. It takes time to set up all of these all of these parameters. There's even a parameter for adding emissive. Should you have emissive? Just take a look. But now we have all of these materials and we have it under mi underscore test blend. So we want to see right away if we could reference this material to act as a material here. So let's try adding mi test blend. Let's save this. And then open your content browser to where you created that material, and again, mi test blend. Hold right click and then copy reference. And then go to where we created the Unreal material. So we want to just put that test blend here on the rock that we just created. So in this Unreal material node, there is a section called string. So remember, we just copied the file reference. So again, right click, copy reference, and then bring it to Houdini. Select the string area and then Control V paste what you just copied. And we just have to wait, hold on. See if this is working. I just it's not activating. Maybe I just need to open it again. Wait, let me close Houdini first. Just doesn't want to show. Oh, that's the reason why it won't show, because I didn't put auto update. So now I just update it. Let's see if once we cook this later in Unreal, if it references the material that we just created. So it says here mi underscore test blend as we created. We just have to recook this and then save the asset, re-import it, and then recook it there. So you only have to change, resave it to this process if you're changing anything in Houdini, but once everything is set, you can, and the tool is created, you can just have it recook and change parameters as you wish. So I'm just gonna make sure it's saved. So right click or assets, save asset. It's not showing up because you have to go up a folder, select this and then asset, save asset. Then in Unreal, you have to re-import. And then rebuild. Okay, let's just wait for it to cook. If you see here in the base material we have just 3 materials. We have 3 materials, but some are the same. Let's see. So now it's quite different than this one because we're using different textures, but you can use whatever texture you wish. But I suggest something that's not too busy, unlike this one. So if I want to use whatever I placed already here, I think I'm looking at it right now and I'm thinking that the tiling is too large. So I'm gonna go to this test blend. I'm gonna have this window open so you can actually see it update real time. And maybe one of them is quite big. So let's see and test which one is there. So C2. So it's the blue material that's sort of this main thing, right? So I probably won't be using this massive cliff texture because it has horizontal streaks and it's applying also to the top. So I choose another one. So I like in this one I'd use rough sandstone, so I'm gonna change the parameters to use this normal here. And then the occlusion roughness metallic. So now I can see most of it. The blue region is using the sandstone. And because there is a tint parameter, I wanted to show you this. You can control the shade of it if it looks too off from the other ones. So you can have the edges as this is I guess this is okay, this cliff. But the tint is different, so I would change the tint a little bit, maybe make it a little bit more red. So if you see, the termination is quite rough. So you can go ahead and go back to the Houdini file and then go to the measure curvature and then add these multipliers as parameters into your HDA. I won't be going through each and every one of them because there are a lot more concepts to cover and we're a bit lacking on time, but I just wanted to show this to you. So I'm gonna check again, make sure that the topper and the icicle is there. So topper is there. So if it isn't yet, you just have to include the reference again, another material. So I think it's working fine. The vertex color baking is working fine. As long as you did this material properly. So for you to probably have something successful, you should have your reference beside you so that you can better uh I guess you can better create a likeness of a real rock. So because we have this I think we have higher resolution here and the rock we created, we have more potential than the one if you see it's quite in this HDA, there's concavity and convex. So I put the parameters here so you can adjust how much of this white material is showing the curvature and how much of it is blurring. So you have control over that way. So a step I'd like you guys to do after this is create some variations here on this map, on this third person map. So what I did beforehand was Uh, it does have you will have a Houdini engine folder here, and there is a bake node. So once you create iterations of this, you can go ahead and press bake, and it will bake whatever iteration with the parameters that you set, and you will have a mesh out of it. and it will come out here. In this case, I created several ones. I would like you guys to create several ones and screenshot them and show them later on and upload them and tag me. But this is the main purpose of it, that you need to have different iterations and different models, which we will then scatter. So we will have placeholders next in the landscape, but you will link them once we get to the landscape. So I'd like to close first with the base cliff portion, because I think we had enough time for that, and then move on to the landscape portion. So I'll be going through the file and how to create it and some basics, but there is a lot more possibility. Let's say for this if you create this rock generator, there's a lot more possibility to other forms, other iteration, up to how you envision it. So let's move on to the landscape. Okay. Save this one. Launch. So I'd like you guys to create a new file so that it doesn't get too cluttered, because once you have different geometries, if you have the landscape together with if you have the landscape node together with the base cliff node, sometimes saving it gets confused on which HDA to save, so better just create another file anyway. So done. So let's start. I have to make this quick because we only have a few hours or minutes left. So let's start with a geometry node. And let's have a refresher. Let's look again at the sort of concept sketch that we made. So we're done with the procedural cliffs, and now we have a valley at the center. If you notice, there is a valley at the center which doesn't have rocks, so we're gonna sort of orchestrate that valley, and then we have some sort of cliffs. So it's not just cliffs. We're gonna have in the landscape ridges to receive those cliffs. And I'll go in the overview of what we're going to achieve. So we have in the middle here a valley, and you have these sort of clusters of ridges, bigger ridges. These are actually areas wherein the cliffs that we made are going to be received. So keep in mind that you have several components: a valley, your cliffs, and the ridges. So let's start. So geometry, as usual, change change the name to this is my third iteration to do this, just as to not overwrite. And first, this is the main part, which is a height field node. Height field. So this is your main node that becomes, if you have this and output this to Unreal right away, it will be a landscape in itself, so it's ready that way. So let's change the shape and color. And let's make sure that let's make sure that we have the parameters correct. So right now, its size is 1000 by 1000. For me, that's really huge. I just wanted a small sort of landscape for It can be around 100. For me, I put it at 150. So I think that's cm, 150 cm, I think, or 150 meters in Unreal's measurements. I'm not sure, but I found that 150 is a good size for me, and changed by size to axis. And I made sure that it's a little more detailed at 1024 grid samples. So let's go with these settings. So now I want to start with the valley that we're trying to create. So we start with the line, and then I want to make sure that line is as big as the height field itself. So there's a match size. So match size and use the height field. See, and then make sure that the line is in the direction of the Z. Let's see if it matches the size, and then scale it so that it will take up the whole length. So we're creating the shape of the valley right now. So I also wanted to add the point jitter node so that we can add like swerves. I have to make sure that we have at least enough. If you look at the points here, there's only 2 points. I need enough points to have detail. So let's add 9 here. And then for the point jitter, let's have a scale of 75. So if you remember, we had 150 across. So if we put it at 75, it means and have the axis scale 0 at others. We just want to pick one axis, or in other words, the x-axis, so 1. So the scale at 75 is saying that you have a maximum of half half of the size of the height field. So you don't want the entire valley to take up the whole space. So just probably at the middle, that's how we're orchestrating it. And now we're gonna add the resample node. And with that resample node, we're gonna change the length to 10 and then change it to subdivision curves so that it's sort of curved that way. And later, I want you to remember that the seed is what we will be using as a variation. So if you change a seed here, it will actually change the shape of the valley. So after that, add the sweep node so that we'll have in the sweep node, change the input to from quadrilaterals to to second input to round tube, and make sure that it's big enough at 10. And I want to apply a scale along the curve. So I'm gonna select all of these points. I want to make sure from this point, shift to that point to make sure that it's at Catmull Rome so that the curve is sort of not jagged. So if you reduce the other parts, it's like we're creating an object or the valley that is bigger at the center and smaller at the end. Because we want, when we're funneling the angle, we want it sort of um we want the cliffs to envelope and not have a big gap at the end. So probably have a very small one at the end. Like that. And so we will use this as a masking object for our height field. So let's put in the input height field mask. Okay. Chef mask, project, or HF project, height field project, or mask by object, mask by object. So terrain to mask, let's use this one, and then object. So if you see it right now, it's very it's kind of defined. So and I can see edges, so I'll probably add more than that. So let's make 15 or a little smaller, 5 I meant. Yeah, 5 so that we add more points. And then I'm gonna add height field distort to add some sort of natural distortion look. So or plug in the terrain and then make sure that the distortion is distorting the mask, not the height. So if you see, it's adding some noise to the mask that we just created. You can add amplitude as you wish, but I'd like to keep it relatively low at maybe 4 or 5 that way. That way it's not too extreme. So we have it at 13. And then now I want to use this as I want to have this valley lower than everything else. So what I'm gonna do is I'm gonna blur it. I'm gonna blur the mask and use this mask. Or let's see first without the blur. I'm gonna create a height field triangle. Now, the exercise files are included in case you just want to copy the vex here, but that's what I will do. So the expression goes as float base underscore river height. So we want to create a base river height parameter, which will what do you call this? Just copy the height field angle here. So what this does is I'll explain. We want to turn the mask equals the height. So we can either just use a height field angle like this. So create this base river height like this. You can control the river height. Basically, you're brute force saying that this mask will have a height at -5. So height equals mask. So you're using the mask and turning it into height and naming it here base river height. But sometimes if I don't want to use vex, I could just use HF remap. And then have the height input to layer to the map. I'm gonna use mask and just reduce the output minimum or output maximum depending on what you need. So either higher or lower or however I need. In this case, we're creating a valley that's lower than everything else. So now we want this to be sort of a smooth transition, not just something abrupt, because a valley can look like that, either that. If that's what you want, go ahead, but I want it a little bit more blurred. So you should remember to blur the mask layer, not the height layer. So if you blur the mask layer, it will sort of blur the mask, and that's what you will reduce. So I'd fill remap here and then clear the mask because you can let's add a height field mask here because you can have several masks on top of each other and you just want to keep it clean this way. And in the next part, I want to be able to, so now we control, we have a valley. I want to be able to control the opposite of the valley. So I want to add height to whichever the valley does not touch. So to do that, I'm gonna add an height field mask expand from this node, expand it a little bit, and then blur. And then remember to blur the mask, not the height. And then mask invert. So the reason we're not deriving it from here because we want to have control on expanding it. So, and then from that we add, we want to take from here the height, but mask by this. So we want to use this terrain, but use this as a mask, the inverted mask. So we're gonna add noise using this terrain, but mask using this. So let's see. So mask noise. We want, because right now it's sort of quite big, so I want the element size to be a lot smaller. Let's see if we reduce it. You can actually see noise now. Let's make it sort of 68. And then have the amplitude at 1. Not have it too rough. Let's have it like 2.5 octaves. And a little bit rougher at 0.84. So that's how it looks right now. Now we have the mask, we want some parts to be high, some parts to be more concentrated than the others, because if we don't, let's see what happens. If we add another height field remap. So right now, what we can do is, whatever is red, we're gonna make it higher. So plug in the terrain and the mask, and then let's see if this works. So make everything higher, like that, like so. But we want to sort of have it sharper than this. So then not just have it like that, that it looks like lumps. So we can first add the remap to the mask itself. So before adjusting the height. So plug in the terrain and the mask, and then probably tweak it this way. Oh, let's later mask. So let's see. Well, we tweak this, the mask changes. I want the middle portion to be really high. So, and then have it low here. So I have the ramp this way because I want there to be like clear valleys and ridges. So let's have it that way. And then I want the output, because I want it a little bit more amplified, I'll put the output to 2 maximum. And then blur it. I will blur a little bit. And then remap. So now when we raise it like this, you see clear ridges. Might be too high, so probably reduce it to let's make it 9, 10. So now we have the base height. And blur, a little bit blur. I think that's too high. So I adjusted it. So we can have several ways to edit it. Let's add an height field test. And with the height field terrace, we can add step size. We can tweak the step size and the height, minimum height, compute range, so that it actually takes the height and the top and bottom. I think this is too high, so let's compute range again. And then add the height field distort to add some sort of distortion. Wrong layer. Distort by noise. Let's add some variation. So what I did do is amplitude at 2, element size at 10, so it's a little bit rough. And then mask clear so that you can see it a little bit more clear. And remove the mask. So at this point, we're narrowing it down, but it doesn't look quite like an actual terrain yet. And an easy way to do that is to add an height field erode node. So what we should do first is change the parameters, freeze it probably at 10. Or let's start with 20. So 20 frames, it sort of simulates it. No, 20 at 20, it's too much. So let's reduce the erosion rate. Let's first frame at 10. Global erosion at 0.5, 0.5 here. And then let's reset the simulation to see how it works out. So, for the visualization, this is just colors, but we don't need this as much. We'll need it probably later. And if you see, these sediments are quite rough. And the way we could tweak that is going to the advanced tab, and it's actually debris. So it's in the debris flow, I think. And reduce the water absorption to 0.5. Let's see if that works. And max height at 1 and repose angle at 10. So it doesn't work yet. Okay. Water flow. Let's see if reducing, let's see where we need to reduce. So I am sort of looking where to tweak this so that we can get rid of that very rough sedimentation. So let's see. Let's change some layers. So check the reset debris layer. And I have to check max debris depth. We have to have it at 1, I guess. I think that's the parameter. Nope. I think it's under thermal erosion, max debris depth. Let's try it at 0.5. Precipitation. Try. There, if you remove the debris flow spread iteration, that's what makes it rough and not rough, so sort of remove it anyway. Or I think that it's the checking of the post smooth, yeah. I think if you check post smooth, it will smooth everything out. So if you check again, if you're satisfied with this sort of value, then go for it. But for me, I think I might want to reduce it even more or blur it wider and increase the depth at negative, let's say 5 or 20. See how that turns out. That's very deep right then. So what I just want to see some curvature there. So I think that's enough for me. Fine field noise. Fine field erode, that's just recalculated. And it's working fine with the grid. So another important point that I need to quickly touch base on is adding the cliff scattering. So because we have a lot of nodes, I will have to open up the file and go through there, the file I created earlier, which you do have. So at this point, we're finished with the erode section. And you have, we now need to um, distribute the cliffs, but have some sort of forms integrated so that when the cliffs are there, it's just not standing on something blank. So we need to make sure that where the cliffs are, that it'll also have a sort of bulge in terrain. So that way, we have a tube as a scattering. If you remember, we started with the tube with the cliff generator. So now we're match sizing to make sure when we scatter it, it's at 0. And first, um, have, let's say we want 3 iterations or 3 instances of cliffs that are different sizes. We can uh, add them here as attribute create. So the way to do that is you want a specific mesh to be referenced. The way to do that is on attribute create, and then change the type from float to string, or rather, or no, actually, we're just adding weight. So what happened here was we added weight as an attribute so that we can actually define how much of this orange or this violet or this small cliff or this middle cliff is being scattered. So we're adding weights so that if we want more of the green one, we have like a higher value of this versus everything else. So if you see this, it's 0.1, one is 0.1 weight, one is 0.45, one is 0.45. So we're sort of using this as a parameter to have, let's say, more of this cliff than the other. So just create different instances of this by transforming them. Create this attribute create and add color, merging them in. It will look like this. And when we're using this node called height field scatter, so again, let's derive from where we started. We want the cliffs to be scattered on everywhere where this valley isn't. Or rather, we want the valley to be clear and we want the sides to have cliffs. So from this mass expand, the river, we're blurring it and inverting it. So red is where you want the geometry to be and white is where you don't want it to be. So height field scatter, pretty straightforward. Take it from the from whichever height. Here at the remap, just before we just added the height, and then scatter objects there. And then now that we've scattered the objects, we want the terrain to be higher at these objects so that it could be well received. So for that to happen, we will mask by object again, as we did with the valley. So if you see now we have circles here, that's representing where the cliffs are. And then we blur it. And then this remap, height field remap, is to increase or decrease the intensity. So either you reduce or add the output minimum so that you can see if you want a smaller footprint or a lesser footprint to be added here. So in the model we created earlier, we didn't have this height field layer, but this is where we add on top of this valleys the form where the cliffs will be. So add height field layer, and you want to add two layers together. So, and you have to check that the layers that you'll be inputting will be mask. So you have to blend mask and layer mode add. So you add this height field, which is the one, the ridges, together with the cliff masking, and then you end up with something in between, something that's masked together, if you see. So this ensures that you have protrusions where the cliffs will be, and you just won't have them at the valley. So it will have a nice sort of transition from the ground to the cliff. So as we did earlier, we protruded it now and then added a terrace and then cleared the mask and then eroded. So now it will recompute. And then you want to be deleting. If you check I here in the information of the geometry node, there are many different layers. These are the height field layers that are very important because in creating the landscape material, we will be referencing these layers to be read. So if, for example, we have this cliff layer labeled as cliff in small caps, you can reference it in the landscape materials as a layer, and that's instead of having it as vertex colors like initially we had with the cliffs. So instead of RGB, you're having names. So with this, you have potential to have more layers than 3, more than RGB, because you have names and the data is inputted to the height field, but I'll stick with 3 anyway. So we need this delete node to sort of delete everything but the height and mask. So if you see, we went from it has mask, cliffs, bedrock, sediment, height, debris, we are going to manually make those or define those later on. So we delete everything but the height and mask. So at this point, we have where we have the cliffs, the actual geometry ready. Now we just need on the next section. We actually don't need this. This is a distribution node for the stones if you need later, which is like procedurally painting the foliage. But now we need to differentiate the layer. Now to do that, there are a series of methods. You have to think about it as you have, what are the layers that you want to put in your landscape? So you have a base material, which is probably going to be the ground, the flooring. And then you have the cliff material, which is the higher, the more steep, the steeper ends. And then you have the ridges or the sedimentation, which are the deposits. So the way to do that is there is a mask by feature node, which is very useful for all of these layers. Height field mask by feature. feature. So what this does is there are several options on which you want to mask with. There is slope, there is by height, there is by peaks and valleys, and direction. So because I decided that I wanted to differentiate the cliffs and the ground, you can use minimum and maximum slope angle. So, or you can mask by height. Masking by height means you're masking by level. So another reason I wanted to explain why I wouldn't create this with you, because if you see other tutorials online for this creation of the landscape and landscape material, it will take several days to complete. So I have to compact this and just explain to you the base features. So it's kind of fast. It's a little bit fast at this pace, but I will go through them. The main concepts you need to know, and you can tweak on your own time. So with the mask feature, you are trying to separate the elements that you want as different materials. So in that case, if we have two materials, we can have a base material, which is everything that is not steep. So let's start with that concept. Everything that is steep is red, and everything that's not steep is white. And we can have two layers named sediment and cliff. So uh, with that in mind, I have to show you how the layer is actually embedded into the geometry as data. So let's go through this. So I added a height field with a minimum and maximum slope. And I also wanted a certain threshold. I only wanted at the middle portion, you will have that sediment. There's no sediment on the very top. No sediment will deposit at the top. So what I did was I put the height field by height, mask by height, multiplied with or added to or added to the or multiplied with the slope. So if you notice, I added this, like, I wanted absolutely this area would have sediment, because if you see let's go through one of the images. So if you look at this image, everything at the sides, or when you open the render, everything at the sides will be a different material. And it will be defined that this valley or floor will have a lighter material. And everything at the cliffs will have a cliff material. So in this case, I had three. You will have three. So first, I wanted to combine everything at a certain threshold of height with a slope. And the way to seal that into the geometry and make it a specific layer is if you, I want you to take note here. If you look at this information here, this is the layer, you only have mask and height layer here. But after using the height field populator, this is where we actually input the height field layers itself. So with the height field copy layer, you want to take a source mask and copy it to whatever name or destination you wish. In this case, it's sediment. So from the mask here that you created, we added another layer called sediment, which we will reference later on. So this is case sensitive and will be referencing it in Unreal. So after using the mask for whatever layer you copied, you must clear it and then move on to different layers. So you must note that The same principle applies to our vertex color blending in that when we subtracted the values, you can't have too much of R or too much of G or too much of blue. They all have to share in like a 0 to 1 scale. So you can't have R at 2 or G at 2 because it will mess up the how Unreal reads it. So that's why in every portion of the in every portion of creating the masks, I clamp minimum to maximum. So it always has to be in between 0 to 1. You can't have R at 2, as I said, or higher. So you always clamp by height field remap. Always clamp the mask from output 0 to 1 as a range, or else it will not work. So however you wish to differentiate your masks, in this case, there's a cliff, there's a sediment, and there's the floor. So in my case, sediment here at the first part, cliff. Cliff is just these few areas, if you see, these few steeper areas. That's all where I put it, because naturally you wouldn't have that much cliff material on the ground. So what I did was I had mask by feature, and then blended it with I subtracted whatever was already here in the sediment layer so that it doesn't overwrite anything or overlap in values, and then input it as cliff. And then same goes to the floor layer. So once you have all of those layers in place and you've added an Unreal Material link, which we will create as a landscape material. So we're already here, procedural landscape, UE5 landscape material. So actually a little bit behind. So we will create it after this. If you look at the information at this stage, it has height, sediment, and floor. It doesn't have any mask. So let's see, this has cliff. So it should have this. I'm just checking if it includes everything here. So sediment, cliff, and floor. And if you need to visualize it, to check, you need this to check whether your layers can be visualized. Let's change layer 1. So you here in the height field visualize node and check if these come out, the height, sediment, cliff, and floor. So check sediment if they will be highlighted. Yes, they are highlighted as is here. And then check now, remove this and check now for the next layer, which is the cliff. So it is included. And then the floor. So basically you created a landscape and created layers in which Unreal can reference. So same process with creating the HDA earlier. Select everything, and then assets, new digital asset from selection, and then change the file location. In my case, I save it as landscape underscore generator underscore 2. Once you've saved that, go back to Unreal Engine. And in this case, let's try. So I have this HDA underscore landscape generator 2. I'll drag this here. And then it'll start building. So for this landscape generator, I chose not to have much parameters because since I don't want to have it cook again and again, and it's better to sort of see it change in Houdini rather than making it bake in Unreal and tweaking it there, and you don't have much control, but here you know what you need anyway. So if you remember, we had 3 cylinders that we scattered, and if let's just check if it actually works to um, the height field scatter. So if you take note, the lowest value is the yellow colored one. So if we change the weight here, if as we need, so let's say 0.5, adding it, adding the value means of the weight, you will have more distribution of a certain one. So that that's the important part of how of being able to control the scattering. So once you have scattering of the rock, scattering of trees, you can control this way how much of a certain scatter object you want. So now that you have them instanced, um, the height field scatter node will have them instanced here in Unreal no matter what. So they will pop up here when you scroll down as a Houdini underscore output instancer. Now, to be able to change that, if you remember earlier, I asked everyone to create different iterations of the cliff. This is where this will come in now. So once you bake the iteration that you wanted, you go ahead and drag whatever mesh, and then drag them to the instancer. In this case, I think it's quite small. That's why it doesn't pop up. So let's add the scale. Okay. So now it pops up at some of the points as you needed. Now add the taller ones to the next one, or however you want them, and then increase the scale. Okay. And then lastly, whoops, remove that. Make sure that it's highlighted. This one, the green one, have the smallest, probably smallest piece here, and make sure the scale is correct. So I don't want to miss out on the other elements, and we must create the main, sort of the main attraction, which is the architecture. So we have to move on to that. I think we'll be doing overtime a little bit, but this is sort of the gist of the how of the landscape, and then this is where also you check every now and then if um your viewpoints are correct. So I think since we're extending, for those of you who are on tight schedules, I think you can just rewatch this later on. But since we'll be extending a little bit, I'll just have a short break so that I've been talking for a while. I just have a short break so that we can continue this. So we'll be back in another 10 minutes. I think we'll resume already so that we don't take too much time. So we need to create a landscape material for this, and it's much like the material for the rocks, wherein we used an RGB vertex color separation. So I'll go through the process with you. So I'll go ahead and look at the reference material for this portion. So if you need to find the master landscape material, it's in content levels and materials, and the instance is there as well. So this is something I also created in Metaverse Inception 1. But if you look at it, it's just like the previous material, the blend 3 material, only simpler. So 3 materials here, master landscape here. The thing to note is instead of let's put it side by side. So in the cliff material, we're creating material attributes. Um, and then funneling blending those material attributes in itself. So we already have a material here, and then we're blending it to a material attribute here at the very end as an output. But this is much simpler. If you remember at the very start of the creation of the materials, we clicked the use material attribute. In this case, we won't. It's just a normal material, but we're using the node landscape layer blend. And we're using that instead of material layer blend. So the landscape material blend, instead of using an alpha, we'll use the names of whatever layers we created earlier. So you can actually go ahead and open up the blend 3 material that you created, and then duplicate that and tweak the material from there. So that's the only difference from the material layer blend to we're actually using names now instead of alphas. Names instead of the vertex RGB color, which gives us a lot more possibilities in that you can have another layer such as a water layer, a moss layer, or however you want. But I wanted to keep it simple for this webinar, so I went with 3 layers. So let's see how this works out. So let's go into the material itself. Let's open this, and I want you to see that it starting the landscape material, you start with this node that has nothing, and you have to add element. Click on add element, and then this will add certain parameters. And now in these parameters, there's a section called layer name. Now, if you named your layer earlier as floor or cliff or sediment, input that floor, and then another one, add another element, cliff, and then add another element, sediment. So instead of gathering early on everything as a material, then blending them, we're gathering the base colors, all the base colors together, and all the normals together, and all the occlusion roughness metallic together. So in that sense, for this landscape layer blend, we're blending floor base color, plugging it to floor, cliff base color, plugging it to cliff, and sediment base color, plugging it to sediment. And then plugging them later on to base color. So once you've done that, once you've done that, check that it's here. Actually, I added a few more parameters such as the tint, just like we did earlier. But once you've done that, you will have a landscape material that reads each and every one of these differently. And when you create an instance, say let's open up this instance. So again, like the cliff material, we have the tiling as a parameter. And then we have each and one of these textures as parameters, so you can change them. So in this case, we have the sandy part and then a darker portion and then the cliff portion as I described. So if you double click this material instance, the cliff and then the floor and then the sediment, which has a darker tint. So we're just playing with tints between the floor and the sediment. But should you need another mix, it's really up to you on which textures you're going to use. But basically, this is how we blend the materials using the landscape layers. And just a note again, you must ensure that you remap it and clamp. If I go again here, you must, or the other one, do not forget to clamp at the remap, clamp minimum and maximum to 1, or else it won't read it properly. So let's look at it again. Visualize. And then see if the sediment gets colored here, the red. Yes, it does. With or floor. And it reflects as such. Floor here, sediment here, and then cliff. So that's what's important. And you have your master landscape material, and then you tweak here in your instance. All right. So after the landscape material, we have to move on to we still have two items, the main architecture, which I'll go through with the ZBrush integration. So I have to pass through this fairly quickly and then the substance designer material, and then finally the rendering that we all are waiting for. So I'd like to open the architecture portion. And walk you through it. Just wait for it to click so that it can show up and load. So I separated these files earlier, and if you need to open them, some of them will not reference correctly because you have it will be referenced in some of the parameters. So let's just check how to fix this because so if it's not if there are cases that they're not working correctly, you just right click and delete the channel or remove the reference. They should be around this because they're not referencing anything anymore. Earlier I put this in the parameters. So let's check type property. So I added this multiplier of the convexity and concavity um to the HDA parameter, and because I saved this as another file, now it's not referencing it anymore. So if in any case you just have to repopulate the parameters again. Now it's checked out this way. So it should show it like this later on. Let's check if this is working properly. Delete, not working properly. Everything is in 0. So this is the portion that I'll walk you guys through this portion later on. It should look somehow like this. So because some of these channels are no longer linked to um, the same HDA because I saved it again, you're gonna have to just repopulate this according to how you need. So I'll go over it. So I want you guys to take a look first at the cliff that we created earlier. And once you do, you'll realize that this first portion is completely taken from that. So right at when we so if you just have to review the where we did it, and right when we VDB'd everything together before cleaning it, now we're going to add the GoZ export. So if you don't have this, it means you haven't had the labs node installed. I also have a note here in the file on how to check if your ZBrush does have GoZ, but let's have it anyway. Let's go through it. So now once we go to the GoZ export node, we add the GoZ export node, plug it in there. And then when you click here, you have to click send to ZBrush, and let's see if it will open up ZBrush. It is opening up ZBrush. Let's open a new project. and see if it will send. So let's click send to ZBrush, and now it sends it as is here. I think when we clicked it, yes, it did. So let's try it again. Default project, do not save it. Then go back and send to ZBrush. Let's see if it sends this one. Actually, it should be sending this, if you see. So now you may start looking at this and thinking that maybe we can have other improvements to this. So um sometimes we'd maybe want to have clusters. So let's see. Let's open up the sample again. And if you compare these rocks, how they differ, this one is using just one tower, this one is using several, and there's some added nuances to it. But this portion is to demonstrate that you can actually have this in your workflow, that you can bring anything to any part of your Houdini to ZBrush and back. And so let's try starting with this, and then I duplicate this subtool, uh, the geometry in the subtool, and let's try playing with it. So now that I duplicated it, I want to, let's say, move this, play with it, play with the scale a little bit, because we want to sort of scatter things. So duplicate again. We want like a beefier sort of cliff. So make sure you just differentiate the scale and try to make things different. You can also go into the subtools itself and start moving things by, let's say, having the brush tool, the move brush tool, and then increasing the brush size, maybe moving this here, adding some, I'd like to use the clay buildup tool. So I click B and then clay and click C, clay buildup brush, and then I'd add and subtract this way, because this is a quick way to add forms. Let's say it needs to be like horizontal, a little bit more horizontal at some point. I'm just pressing Alt to reduce and add. Basically, this is to show that you can sort of edit the form as you need. Let's go to the other subtool. And I also like using, so this is the clay buildup tool. I also like using the trim dynamic tool if I need to make things jagged, some edges jagged. There's also another way to sort of add edges to your rock. Go back to clay buildup, go to the main duplicate this one, and then bring it up here, scale it a little bit less. So basically, we're manipulating things here. And you can also use the dam standard. I like to use the dam standard. Brush brush dam standard to like sort of add creases as I need to. So this is for adding creases. And later on, we will be mashing everything together to make a unified form, much like how we did with the VDB. So I'm just demonstrating how you can sort of edit the forms as you need and later on tweak them. And you can have this process anywhere and in any part of your workflow. I'm just using a clay brush and then playing with Alt. And smoothing every now and then. And then trim dynamic. Playing with the rock forms as I need. Basically, we don't need that much detail. We're just manipulating the forms as we need. As I mentioned earlier, if you need a specific silhouette, this is actually what we're going for. Like if you need the rock cliff face to be really large at this part. And kind of blocky, and a form that like you never, like we had a specific form with the Voronoi, and now we need a form that's actually not that shape. So you play with it this way. And then once you're sort of done with the sort of massing that you have, I'd like to use ZBrush to remesh and BDB everything together so that it's sort of one cohesive piece. So the way to do that is from Subtool, in the Subtool panel, go to Remesh, and then pick a resolution that's probably nice enough and detailed enough to give enough detail. So let's see. Let's see with the 480 resolution. Let's see this. I think this is good enough, and it's, if you notice when you press remesh, it all sort of BDB'd into one piece. And this is what I meant, that this is the this is why this portion helps a lot, because you're able to tweak the silhouette as you need art directing right in the middle of the process. And we can go back to Houdini and continue the usual workflow. So let's turn off everything and send everything now to Houdini. So in the file that we created and that I sent to you, we have a GoZ import node, and I froze it so that it doesn't change when you don't have anything in ZBrush. But in your case, when you're creating something new again, add see GoZ. It will take whatever is in ZBrush. So if you highlight this, it has nothing. So let's go back to ZBrush and then make sure at the right tab, at the Tools tab, there is a GoZ node here. And to make sure that you have it installed, I think it's in Preferences, and then GoZ to check. And make sure that there is Path to Houdini here. If it says Houdini application was not found, you just have to click it and it will detect which Houdini version is there, and click on the version that you need, Houdini 20.625 in this case. I clicked it, and then let's see if when you click visible and GoZ, does it sense, or just click visible? Let's see if it sends to, actually it was probably opening up 3S Max, which is not intended. So let's see if while reloading it, So I reloaded it, and see, this is the exact model that we were sculpting earlier, and now it's referenced as needed. So um, this is what I created before. Just stack things together, and once you needed like a different silhouette, like something blocky and squarish, just add it to ZBrush, go Z export, and then import them back in. And then this is where you can really tweak your forms, or you can go with a normal process. Just plug in the cliff. Don't skip this ZBrush process if you don't need it, and then have everything procedural if you want. For me, I can add actually I can add a switch node to switch between um this piece and the cozy import piece as you need. So you can go from you can use what you did procedurally, or use either which. But for me, I think the purpose of this is to show that you can use ZBrush, so I'll use this instead. In this case, I won't use the one that I created, but whatever is here. Actually, you can. Let's see if it will apply, if it will change. So let's see. So now we have a match size to make sure that it's on the ground. It's on the right plane. So match size and then offset it a little. -1. Remember to put none on X and Z and justify minimum, offset it by -0.1, so that you have a little part eating up in the ground, and then as if you remember, this lower portion is exactly what was in the rock tutorial or the cliff tutorial as well. We just cut it in half and inserted the gozy. So it will follow the normal process of match size, poly extrude, and the attribute transfer. If you remember, we had this weird normals in the first part, and then we're adding a horizontal noise and then adding back in the normals, if you remember. So we're still in that process, and then adding edge damage. Let's see, the processing of edge damage. So it did add some, because there's so many forms, it's hard to tell, but there are some. This area was sort of flattened a bit. You have some edge damage here. I think I'm good with that. So just continuing the process as we had in the cliff. It's exactly the same. Just plug it in the middle and have ZBrush as you need it. And we have our first element, which is the cliff. So what we are trying to do really is to have an architectural piece wrap around the cliff. But in this case, in this specific file, we had an element that we sort of curated, and we wanted it like sort of imposing and sort of tall or sort of different from everything else. But we wanted the speed of having it sort of procedural at the start and using the um same sort of process. So this is where it funnels out. We start with a match size, and this is where we start the architecture portion. And so I just added a null here so that I just brought the wire over here. And the concept of this architectural piece is we have a series of tubes and clusters spiraling around the cliff. And the reason I did that because I wanted something sort of continuous still, but having different pods. It's really up to you how you want the configuration, but this is just showing that there is a sort of, it's basically distribution along a line. And I just chose a spiral. You can choose a different sort of line, or if you want to add noise later on, you can. So we're going to be scattering around the spiral. and we're gonna be adding forms. So I brought in the cliff, I'm adding the bounds and then transforming it to be smaller. And I'm using this form that is smaller to sort of size this spiral. So I'm sizing this spiral now. It's basically a spiral node that you can just bring in and you'd be met. It would look like this right off the bat. So you can either tweak the turns as many as you want, the height, and then the start and end radius. So with the match size, if you see, if I highlight this, I'm actually wanting to wrap around it before I sort of squeeze or project the spiral onto the cliff. So the way I did that was made sure that I reduced the scale a little bit, make it higher. This is another level, just another level of control, this transform node. And then we have the ray node. And the ray node, the way it works is it's a projection, and that you need to plug in first the line at the first node and the mesh for it to wrap. So right off the bat, if you check it, it actually, if you use it right off the bat, it doesn't wrap around properly. So what you need to do is minimum distance so that it takes the minimum distance, and whatever nearest point it hits, it takes that. So I'm gonna unhighlight this. So if you see, it actually did wrap around, and that's my purpose, to sort of have the spiral really hug the cliff so that when you scatter the architectural piece, it will really look like it's conforming. So I resampled it to have better control of the points. So initially we had these points and they're not properly spaced far apart, and then I resampled them and then delta mushed them to have them a little bit more smoothened out, and then a sweep node. So this sweep node is actually the main backbone, or if you should say, if you could actually say it's the passageway, it's the pathway of the that connects, or the hallway that connects the pods together. So so now we have the backbone of the architecture piece. Now in this section, architecture base form, we are actually kind of at this point modeling with Houdini, sort of just modeling. You can actually create whatever you want as a shape of a pod, but I started with a line and then resampled it and swept it. So what this does is it creates a sort of capsule that if you use a round tube, by default, it's on second input, but I put in round tube and grid type end cap. So if you don't, usually this cylinder does not have an end type, an end cap, but since I put it, gave me the opportunity to have this sort of bulbous shape at the top. And you can adjust the scale as you wish or as you need if you want it flattened a bit, but this gives you sort of the base shape that we need for the pod. And the transform node just adds a little bit more control if you need it later on, because once it's scattering, you need this level of control to say maybe, oh, the pods are too big, the scatter too big, so you need this transform node to make it smaller. And then this one is important. So I extruded the end caps. I wanted definition between the windows and the top parts. So I took the group end caps. So if you go back to here, the sweep, there is an option to end caps group to put input end cap group, and then reference that in the poly extrude, and then um add distance to that, and that plays as your roof. And then you can match size it before copying to points. And if you remember, we had this a line wherein we were going to scatter the capsules. So from this line, you're gonna scatter points, and it's important that you have this like sort of total count. You can have this as a parameter later on how many pods you need, but in this case, I didn't have it as a parameter. I just had it as a force total count, and at just a randomized p scale. If I didn't clearly expound on this early on, it's attribute randomized, change the attribute name to p scale, and then minimum value at 0.5 and 1. And then this funnels out to the points that you're going to copy it into. So if you see this, you have the capsules, and what's important is you have these groups, the end cap groups, to differentiate the windows. So the reason why there's a group expand here is because without this, if at 0, the end caps will only be referencing this part, but we extruded it. So I added a group expand to even reference this lip. So moving down. So later we will funnel that out into this part of the script to sort of separate things, but we'll continue with the merge first. So we're merging in this section, we're merging the middle form, which provides continuity to the whole architecture. So this is the hallway. And then subdivide, and then VDB everything together. So in the so I'll be picking this because I have a certain parameter that I adjusted that sort of conforms to everything, but I will show you this to explain. So so having this in mind, the initial sculpt that I created, actually we'll use the one that we just created now. I'm looking at this VDB and I'm thinking, oh, the pods are too close together that they actually touch. And this is what we want to avoid for the purposes of unwrapping the textures. So we had this control of transform. If you remember, we had this transform node, um, and we have a scale here to add if needed. So I can increase the transform of the spiral to sort of have everything spaced out if needed. So let's go there again. Here at the convert VDB, now you see it's a little bit more spaced out. I just want enough space so that it doesn't really touch one another. Let's have it at 5. I think I'm good with 5. It's now spaced out well. And then the delta mush node is added there to sort of relax the points right after VDB. Now we're also using the same principles of adding noise because again this architectural piece is supposed to be sort of camouflage but not too camouflage with the cliff. So we're using the same displacement, the linear horizontal displacement as we used with the rocks. So let's check it out. So again, exact same principle, create a tube and then transfer the normals. Transfer the normals. As you see, it looks exactly the same, and apply the same noise. If you look again, it looks the same. We have that sort of horizontal breaking of the form and the detailing. And we could stop there, but for it to be looking more sleek, like something architectural, I wanted to process it further. I wanted to process it to make it a little bit sharper and fix the edges, not to look exactly as the cliff that we created. So if right now, if you add it to the cliff, it'll look like it'll blend in just fine with the cliff, but We want it to stand out just a little bit. So I added the Labs Mesh Sharpen node. And this node actually does a lot. So it comes from this and it takes whichever normals are sort of prominent and sort of smooths everything. So if you see, it actually moves the points together to where it's sharp. So it actually tweaks it a lot. But what this does, it creates a high concentration of points in where the edges are. So we want to sort of slowly fix that so that when we add a curvature node, it works well and the blurring iterations of the vertex color are distributed evenly. So after doing the mesh sharpen, we do the VDB again. We VDB it again so that it's not it has a nice, we're sort of fixing the layout of the polygons and then convert again. So right now we sort of lost some detail. Delete small parts to ensure. And then now I want to separate the windows. So now we're incorporating the windows. So let's go to this portion where we separated it. It's actually this portion where I group it. Let's put it here. So if you remember, we had the end caps, and now we're going to blast the end caps and thicken it to make that sort of window group. And this will be used as sort of a selector. We will use this as a selector like a bounding object to select all the points on the VDB of the architectural pod that we created. So we'll follow this VDB from polygons, convert VDB, and then now use this as a bounding object as I mentioned. So keep in bounding regions, bounding object enable, and points. So if you see referencing it, you will have these points. So now we grouped separately the top part and then the windows, which is good. Now we're gonna bring this over all down to be selecting the sharpened mesh that we opted for. So if you notice, there's the windows that aren't sharpened. I actually used that group to avoid being sharpened. So if you see now, we have the windows referenced. Then I wanted to color it to have a different attribute. And by we needed to color this to have a different attribute so we can take advantage of this group from boundary node. And then that we have the edges. So it has to be group from boundary and then group type edges. So we can use this edge smooth to process everything so that the termination is better. So edge smooth node, take note, it's at 10,000 strength. At default, by default, I think it's at 500 or 1,000. So if you check it and see what it does, it smoothens out that specific group of edges. And now I want to make sure with this series of grouping that it's still, the windows are still grouped away from each other, and I want to sharpen that. So now from the grouping, I added another layer of sharpening. And if you notice, I have to do it again and again to have it less aggressive. I want in the end that these separation of points are less aggressive so that they can be smoothed out. The normals will be smoothened out, and then the vertex colors will be read properly. So group expand, group promote. You want to make sure that the window groups are always there. And now in this area, we split the windows with the tops and process them differently. So with the windows portion, we remeshed the windows. Let's see. To sort of, this is the optimizing stage. So we're done with the windows in this portion. We're remeshing them. softening the normals, and then doing the same process that we did earlier with the auto UV layout. And now we want to have a differentiation again with the vertex color distance from border. And that it has a different color for the polygons that are closer to the edge. And then the same method I did with the blue vertices earlier with the RGB and the blue vertices. I derived the CD, the color that's black and white, input it to blue, and then exported it as a color again. So we go from black and white to red and green, and then adding an Unreal material to reference that. And this area we just add a frame. So for that to happen, you get the borders of the windows by putting a divide node, and make sure to remove shared edges, and then click ends, and then make sure to put close hue on row with shared points, and then resample the node, delta mush to make it a little bit smoother. And then if you notice at this stage, you don't have good normals. See, you don't have normals yet, but we need normals for the sweep to work properly. So we add polyframe node, and make sure in the polyframe node, you have in tangent name normals and at two edges. So add the sweep. Don't forget in the sweep to have to compute UVs and have the surface as a square type for the border. Add the color, Unreal material, and then let's move on to the top section, the the roof. So now we have the roof again. We remeshed it to have a little bit more optimized. So we're doing this process of remeshing it again and sharpening, remeshing and sharpening until we get the mesh that we really want. And to take note to control that right here it says edge length adaptive, and you must select adaptive instead of uniform so that it will distribute the triangles as needed. More triangles in places that have more creases, and less triangles at the places that have less creases. So it's pretty much more optimized this way. And after this, we add another mesh sharpen that's very light compared to what we had before, which was 10,000 or 1,000 hundreds. And what this just does, not it sharpens it very slightly, doesn't pull all of the edges together just enough so that we would be able to fix the normals properly. So right now, if you look at it, the normals aren't as crisp. Um, but because of this process of remeshing and then sharpening, remeshing and sharpening, we get sort of a nice polygonization of your mesh. So now when we soften it, you see that the edges are quite crisp and there won't be too much janky edges. So same process, auto UV layout and measure curvature. See? So at this point, and then see once we blend everything together, we end up with this. So I don't think it was blurred enough. Let's see, let's put it at 20. I think 5 is great. So this is great. We end up with this portion of the architecture. We used a different mesh. We used a different sort of ZBrush. And let's see how they are together. Let's just wait for it to cook. I really apologize for extending time, but I really needed to go through the process at the start of the initial ones that are repetitive so that you could really follow later on and apply this on your own. So I'm just checking, yes, it still works, but later we're just gonna take care of these wires. But because everything's procedural, when we adjusted it, things became this way. So what we're just lacking are the windows and which is the final touch that I added, and some cables and in the top part. And these are instances of antennas which you can replace in engine later on. So let's see how the cables and windows and antennas are made. I think that's the last portion before we move on to the texturing of the Substance Designer. So with a window shape, it starts with a tube, but basically this is just plain modeling. You can have the windows any shape that you want. So um, there's a polyfill to have an end cap for the tube, and then the groupings so that you have the purpose of this grouping is to remove the back end. And then now the purpose of this is I want to differentiate the vertex channels again, so I can differentiate which is one material, which is the end, which are the mullions, and which is the glass part. So just in the purpose of separating them RGB wise. So group combine, I'm trying to create groups out of this outer portion, this middle portion, and the mullions. And slowly just using a poly extrude node to play with the form and sort of create a mullion, and at the middle will be the glass portion. And now what's important in this section is how I did the UV layouts. So the first unwrap is unwrapping everything, but I wanted to have different settings per group because as upon looking at it, I wanted to have it a little bit more optimized. Because when we create the Substance Designer texture, it's all about this window. So this window, I wanted this circle to be laid flat on one texture map. So first, this portion, concrete portion, I had it laid out this way with an XY projection because I was experimenting with XY between XY and YZ to see what looked better. But basically, you needed to separate these because they don't work all well with one projection. So if you see here at YZ projection gives you a totally different result, it would be fine, but I wanted this instead. And then next would be the glass portion, which I intended to have um just that's one piece at the middle, and I had the scale to maximum to have it laid out. So what this UV layout does, it packs all of your geometries into this one square, or however settings that you pick. With the mullions, I had a mullion group, lay them out that way, and now I split them. So splitting them, I needed to split them to apply different colors to each. So split and then color green, split and then color blue for the glass, having to reference each group one by one. So color glass, concrete, glass, and mullions put together. Basically, you could do this in any other software as you needed. Reference them later on, but I decided to do them in Houdini. Adding normals, and then adding a transform as needed, and then copying to points. Now, which points are these? Now, I wanted to scatter them all around simply at the Windows portion. So what I did was from this um, Windows portion or this middle portion, I added a circle. I sized a circle to this capsule so that it still remains procedural should you change the size of the capsule or whatnot. You have a circle that has a polyframe. And what this does is, because you're gonna scatter windows all around it, you don't want the windows to be pointing upward, but from outward in. So to do that, you have to add the polyframe node and add tangent name n to two edges, and then match size. Size is and then you have a transform node to the adjust the circle, which in turn informs how the windows are scattered. So if you check here, you depending on how you scale them, they will either go inward or outward of the capsule. So after that, I from this point I packed and instanced it. So each and every window is one instance, which makes it a little bit more optimized for the engine. So they don't have to have separate meshes for each. So just one cylinder is one window, and then later on copying it to all of the pods, which was derived from this portion. It was derived from the points on where it was scattered. And then add the Unreal material, and then now we have the windows. The last two are the cables and the antenna. The antenna is basically the same way we did the icicles. So now we're masking everything that's at the top point and remembering that to check cast shadows and self shadows. What this does, it only adds antennas at the very top point where there are no shadows. So basically, the antennas have to point to the sky and then scatter in a line so that everything will be aligned. Remember to blend normal with Y in this alignment tab, so everything points upward, and then copy to points. And with the scatter and align, it also randomizes the scale a little bit as well, as long as you add this minimum and maximum radius to be different. So this is just another form. A tube form is a placeholder. It can be a box as you wish, but it is a placeholder for antennas that you put in. Just like the instancing of the landscape, you drag in the mesh to that part of the HDA. So taking off the normals node, what we just lack now is are the cables. Let's see what the cables does. So I derived this sort of form from where before we sharpened everything. Just after the first sharpening, and that we extruded it -1 so that when our cables attach, they're actually embedded just a little bit. So we needed this poly extrude node to bring in everything together a little bit. And then we needed this ambient occlusion. If you put it to CD to see where it's showing CD. If you see the scatter, it's only scattering at the bottom. It's the same way we did the icicles. So this is at the very end, also the antenna. So at the very bottom, and then check cast shadows and self shadows. So it'll only all point to the ground. So the cable points will all have direct looking down to the ground. Just -1. So after scattering, this is the important portion. You have to sort the points. So it has to be even so that there will be 2 points connected to one another to form a cable. So even numbers only. And then points sort from top to bottom so that when we add the points together, we won't have cables that are running across. And then the add node, which is important when you add the add node, by default, it starts by points. You have to go to polygons tab, by group, and the number of points every second, every n points it will connect. So if you see, it connects the points together, and that's our starting line for the cable generator. And the cable generator is a labs node that you get with by creating the labs package, installing the labs package. It's very simple. Just plug in the curves that you need and the collision mesh. So in this case, we have the cliff as a collision mesh. This is a cliff, and we want the cables to simulate that they're hitting the cliff, or there there's friction between that and the cliff. So after plugging that in, um, let's try it by default. If we do it by default, we start with very huge radiuses, and now we can start by really dialing it down a little bit, reducing the radius that way. And then let's say we only have since we had 4, the spacing was just so far apart, we have to dial it back down to maybe 0.1 again. And then the spacing variation was just so large, let's make it 0. So we have 4 cables here, it still doesn't have any sag as we expected. So what we could do would be we can start with pseudogravity, and what it does is it simulates a gravity that's not simulated. In this case, I'll show you how it looks like if it's not including a collision, which is the cliff. This is the simpler way. I think this could do anyhow. And let's see the minimum and max which you need to tweak. I think some are really sagging below, so let's just reduce the minimum a little bit. And because it's actually very janky this way, you can add the resolution. So if you reduce the number, the resolution increases this way. Probably make the cables only one main cable and then add sub cables as needed. Again, reduce the size, random scale, and then add ends. The add ends adds a pipe here, and then you can plug it in. See how it looks like. Now it's not simulating, it's fine with me. Or you can simulate it. It will be good to simulate it as well. But it's too long in this case, so let's see if you could reduce the simulation. Try stopping it at 2. Okay. Reduce the cable size probably at 1. And so it doesn't sag as much. So I think more tweaking could be done, but I think I'm good with that. So these are the cables, antennas, and again, plug everything into a merge, select everything, and create the HDA as needed. So that concludes the third part, the architecture, which is very similar to the cliff, just has the different nuances. I'd like to invite you to download the file and check it out and follow along on your own time. But for now, we'll be moving on to the texture. So let's look at how it's very simple. It's just it's it's just a simple geometry. It just shows how I didn't add as much network boxes anymore, but it shows how you could um input use Houdini as geometry and create textures and materials out of it. So we start with the grid, and in this sort of form experiment, I wanted to use the sci-fi panels as a main form. because this is sort of like a sci-fi desert theme, and I wanted to have some element of it being sci-fi anyhow. So sci-fi panels, and then I match sized it to the grid. So we will be using this grid as a reference as well for baking. So I want to explain these concepts first. What we're actually doing is we have a flat plane and we're baking the geometry onto that plane, which will in turn show textures and which we will bring into Substance Designer. So it's the same concept as having a low poly mesh, a flat plane, having a high poly, which is a high resolution mesh, and baking that data of the displacement into that flat mesh, so that that flat mesh will represent the texture, and you can apply that to any mesh that has a UV unwrapping, and it will reflect that texture. So let's see how it's done. So we have the sci-fi panels, just a match size to the grid to make sure that they're on top of one another. And is this open? Let's see. So what I want with the sci-fi panels is not to get these, but to get the opposite. What's in the middle? What's in the subtraction? So what I did was Boolean subtract between the grid and the sci-fi panels to get this part, and poly extrude, and make sure to output the back to get this form. After getting this form, I process it with the lab's edge damage, and then add the match size. So I needed to join these two so that you have a glass pane and the mullions that are sort of looking worn and broken. And I ensured that the mullions group were using the A outside B. And the booleans, you have to check some of these output primitive groups. And it happened that the A outside B was the right group to select to group the mullions. And the next part, we're grouping everything and subtracting the mullions to get the glass group, which is this. And then now attribute delete, deleting everything that's unneeded. And after having the mullions and the glass, I wanted to have another layer of sort of maybe dirt or dust, so that have another layer of detail. So from this portion, I brought it here to the right, to treat it like a sort of a height field, because I found that the height field erode node was very useful in creating sedimentation. So that's what we're doing now. So creating a height field and making sure it's just about the same size as the grid, 5 by 5, 5 by 5 here. And then I projected the mullions so that it would take its shape, and then remap it to make it a little bit higher, so that when we erode it, because when we use the height field, it will erode, the mesh actually melts. So if you want more of that definition to stick out, I remapped it to be higher. So if you check this height field erode, let's try to reset the simulation. This is something we did in the landscape. So we still have what are we trying to get here? So we still have the portions that are higher, eh, and then now we have the portions that are lower. So what this does get us is we have sedimentation in the panes where the parts of the panes are. So we'll be mixing it together if you check later. So you need this convert height field to polygon to have it as a polygon here, and make sure to extrude base. If you see it's transfer, if you see it come together later on, we're gonna add the color to differentiate it, and this will be seen later in substance baking, and to add the material. So if you see it here, let's try to remove the materials. so that we can see the colors. So now we're using the same RGB method. And if you see, this what the sedimentation did was just have a little amount of dirt where needed, where the mullions are, because naturally, in a natural sense, that would sort of happen. So we have this this window going on. And what we do need in the end after we have this, so we do have um this geometry prepared already. We need to now bake this high poly geometry on a flat mesh. So what I did here was I used this grid and then I brought it down just a null, just to bring down the wire. And then I added the UV project node and it's orthographic just to ensure that let me see. Just to ensure that this grid uh has a UV layout of this exact tile. So that's what happened here in the UV project, so that when we bake it, it will be exactly projected to that. So we have a labs maps baker node, which we need. And then it says here the first node input low resolution geometry. And next the high resolution geometry here. And then what this does is it bakes it according to where your output is. So in this case, I want to preview, let's say, I want to have material ID. I want it here, material ID, or let's say colors, vertex color. So because we had colors here, once we bake these maps, as long as you, depending on what you check, it will get outputted to this output directory, hip, render, and then your map name. So for me, though, the only important ones that I will be using, take note, I'm okay with this 1K by 1K resolution already. So I need the normal map vertex color to differentiate the window from the glass to the dirt, which is this part. The ambient occlusion, which I can just plug in later on, and the height, and then I'm not sure if I needed the material ID, probably not anymore. But once you hit render, it will export to the renders tab. I'll just show. So in this folder, there is a render folder. So if you hit render, it will export whatever maps that you need here. And these are the files that we will link back to Substance Designer later on. So let's open Substance Designer, our last portion before we fix the landscape itself. So this is Substance Designer. I'm gonna open our recent package. But in your case, if you create a new package, click on File, New Substance Graph. Let's see. And then click on the metallic roughness portion, and you'd be okay with this. So I'm just gonna have a brief explanation of these. So these are your outputs. Base color, normal roughness, height, metallic, and just like Houdini, we have nodes, which later on funnel here. So whatever ends up to this node, the base color, normal roughness, those are the outputs that will be sent out or exported. So let's open let's say this pod roof that I created, and fast forward. This is what just a summary. This is what it will look like. So you have the differentiation, the glossy glass with the mullions and the dirt and some parts that are emissive. Okay, so we start by um, going to this package and then hold on. I'm gonna close package that we created, or rather, we're just gonna go straight close this and open it again. So let's go to the recent packages, and in the resources tab, actually, you can add in resources tab, you can click. You will have this folder right off the bat, resources. If not, there is an file. I think you will have this resource, or either that, or you just drag and drop. You drag and drop this over here to be. You need these resources in your shelf to be able to reference it. So, um, these are actually by default linked. So when you sort of change anything in Houdini and re-upload it here, it will just update as needed. So I wanted to show how I separated the materials here, just like I do with the vertex blending in Unreal. So I dragged the color, the vertex color here, and then separated each and every node via a color to mask node. So type in color to mask, and if you input it here, whichever color parameter you chose. So in this case, you can use a paint dropper tool to either select the blue, select the red as needed, and it will reflect here. So in the left side will be the material 3D viewport, and the right part will be the preview, whatever selection you have. And then in the middle will be your graph. So use the color mask to separate the R, G, and B, or the mullions, the sediments, and the glass. And then we have several ways to sort of process them. In this case, we use this mask, or the mullion mask, as a blend node. So um, blend nodes are also used here as in Unreal, that you have two colors and then you use an alpha. So just an example to use this is you have a blend node, and then you have a uniform color. Let's have uniform color here. Let's say black, or green, or let's say yellow, and another uniform color, yellow and green, and then use the color mask as an alpha, just like in Unreal, and then you have this color differentiation. Now, in this case, you're using, just like with the same principle with what we did in Unreal. First, we blend first two colors, and then those two colors to another color to create three layers. So this in turn plugs into the base color, which is by default here already, and then the normals, which is a direct output. So we have this already from Houdini. Plug it in here, and then we have the metallic. In this case, it's important that you create this output, because if you remember, we have a map, and a occlusion roughness metallic map that's compacted. So this is an important part that I need to show how to create. So we package the textures together so that it will be referenced in Unreal the same way we created the shader. So I want you have to think when you're creating the material. So first, occlusion. Occlusion for R. So occlusion, we can just take the gray map or ambient occlusion that came directly from Houdini, and have this. There's a node called RGB A merge. So this is where we merge all the gray channels into separate R, G, and B channels, so we can create a compact map or compact texture. So ambient occlusion goes directly into R or red. And then for roughness, I knew that that the least rough or the black part would be the glass, and the next would be the sediment, and then the most rough or the white would be the mullions. So I used a blend layer node to blend the sediment with the mullions, and I just added opacity. So again, blend and blend the two here, the mullion, and then just opacity. So just play with opacity, just like in Photoshop. So to me, I thought to myself, I'm good with this sort of roughness map. So now after that, you can directly now input it to the green channel. So that's where it comes out as green. Next would be metallic. So I know that only the windows are metallic. So I took the windows, the white part of the windows, plugged it in here. And then now we completed the occlusion roughness metallic map. So what's important with this is it's not on by default. So you need to create an output. So once you create an output node, it automatically reflects here. So whatever you have here, it will reflect here. So now we have to create an output node and add a component that says RGBA. So we're good with that and just change it to ORM. I think that's just a label or occlusion roughness metallic. Ambient occlusion, and then plug this in here. Rename output to ORM, ORM1. And it reflects here, and later on when you export it to Unreal, it will export the ORM map. So we had that completed. Again, we have the base color, normal, and occlusion roughness metallic. Now we have one element left, which is the emissive. It's a touch that I wanted to include. So what I did was I created a tile sampler. So by default, it's like these squares, and I wanted like some sort of like variation between the squares to come up with a sort of matrix like black and white map. So I went from square pattern. You can have a different X and Y amount, and then the size would differ from X and Y, and then you have sizing to be random, and then position random as well. You can have them like this and have offsets. Just play with the parameters of the tile sampler, which I then came up with to get this sort of emissive map that I wanted to sort of multiply. I wanted to ensure that this emissive map will only be reflected in the mullions. So um it's not. So that's what I included here. Blend map between mullions and the tile sampler. In the multiply mode, multiply actually gets the white, which areas of white, and those are which areas of white are there from the two maps and funneling them back in together. So now we finish the graph. Hit save and remember to right click. The way to have this, so in itself, the substance graph won't be read by Unreal, but what you have to do is to right click and publish a .sbsar file, which is a substance graph archive. And this is what will be read in Unreal. So if you go back to Unreal, to make sure, you have to make sure that you have open plugins and substance, click on substance. So for you to have this substance plugin available, you need to go to Unreal Marketplace. Let me show you. And then go to Marketplace. and then hit on type substance. And then there is a Substance 3D for Unreal. Download that and then apply that to your engine version so that you can check this plugin Substance, and then you'll be able to drag and drop this SBSAR file here. Once you drag and drop, I want to show how it looks like once you drag and drop. You drag that in. Right, let's try to import something else. Let's just save a copy of it. So if I drag and drop in the archive that we just created too, actually I accidentally clicked the SBS file. So you have to ensure that we publish SBSAFR file and then name it to. Name a copy of it and then publish. And then make sure that you can now see it. That's delete, it's not needed. SBSAR podroof 2. See if we drag and drop it. This is what will be integrated. And then you have this import options. So by default, create material substance default will be good with this. And when you import, everything will be loaded this way. And you just have to sync and unsync. So I'll delete this. You can, again, the same way that we differentiated with the textures in the RGB way, it's the same way that you're gonna add these textures. So I'll delete these and show you what I'm talking about. So because it's loading very poorly, I'm going to delete this landscape generator first and have everything here. So once you bake the architecture properly, let's plug it in here. Right. So see, let's go in the map that we're creating the desert biome. Let's go to this portion and see that let's look at this area where we differentiated the windows from one another. So if you see, this is the texture that we created in Substance Designer. Let's see where it's referenced here. Since it's still an HDA, it's a reference from Houdini automatically. But I know that we created a substance window. So let's see, pod opening. This is where we inputted the substance graph textures. So you just have to, like how we change the textures in the landscape and the cliff and everything else. We just use the substance textures and input it directly here, and we have what we need. So I think we can close the part 4, and we could just briefly touch, because we're really out of time. We can just briefly touch on the foliage painting and the rendering. As I as I promised. So with the foliage painting, the procedural scattering of this, we sort of skipped it in Houdini and went and said that we needed to art direct it and have it here. So what needs to be done to have this achieved is first have the rocks and the foliage as you need by adding the Quixel content and downloading the necessary um items that you need or you chose. And in this case, we have rocks, dead branches and trees. And to be able to activate this, I'd like to put it in unlit mode so that things could perform better. We get the messages. Hold on, let me drink. So we get the Pixel content. Let's open it in Megascan 3D Assets. It will be here once you download it. And in this case, we have, let's say, a cactus and go from selection mode to foliage. So the way to have this is the way to have foliage here is it's not yet a foliage until you drag and drop it in this foliage creator. So let's see if we drag and drop this cactus mesh, download this cactus mesh from Quixel. You have to drag it here, this foliage type, and then it creates the foliage. And then if you see the others are not checked. So it only distributes itself if it's checked. So first you have to go to each and every foliage and define the settings. In this case, I want, let's say a little bit more than 100, maybe 500 pieces per maybe cubic kilometer. And then let's see, let's first see at 100. So it's too sparse and far apart. If we change it to 500 and then first undo that and then change it to 500, we're actually setting how much of it we paint in this sort of brush. So now we add 500. We add density. Maybe add 1200. Maybe that'll be good. Now we can add cactus. So you have, depending on the parameters here, you maybe play with 0.75 to 1.2 of a size. So you have sort of variation. See, there's some variation. And now you have foliage to be painted. So how this was composed was I wanted to have the bigger rocks only in the flatter portions. So what I did was the flatter portions, I had them only at the ground slope angle of 10 to 25. So it only appears at 10 to 25. So no matter where I paint, it only will appear there. And then same with the other foliage, they only appear at a certain height or a certain slope angle. So that's how you'll be painting it. And if you notice, not all the portions have foliage painting. I set initially that this will be sort of the focal point. So we'll only be populating most parts here. That makes it very efficient and for the engine and makes it easier for you to work. So with that said, we can move on from the foliage to creating the movie render queue or the movie and then the sequences. So before that, you need to check first. I actually laid everything out in the handouts for you guys in a step-by-step procedure. Let me check. So everything is laid out here in the handouts. Um, there is a there is a there is an atmosphere setting. I actually today use this myself for myself whenever I'm creating um a blank a blank level. So when you're starting with a new level, you create a level and you're blank with nothing and you don't know the settings. If you follow this, you'll get the basic settings, a realistic sort of realistic settings that's close to what you need after everything. So you have clouds, you have atmospherics, you have a fog. And this is always my basic starting point for any project. This sort of guide that I made for myself and that I'm sharing with you guys. So um once you've done that and you have the basic setup, you put your assets in these HDA, make sure you bake them. Let's go to selection mode. Let's go to the plugins and make sure you have to make sure that movie render queue and additional render passes is checked. So that's your prerequisite for having these render passes. So check that and restart. And then once you restart, you'd be able to render using movie render queue. So the very first thing, I'm only going to teach the basics of how to create a sequence, is that with this map, for example, you need to be in this map to create a sequence for it. So you have to bring this level sequence tab down, this camera icon, and then add level sequence. And then it prompts where you need to put the level sequence. And then I'd like to name it as SQ underscore what map it's in, desert biome underscore the name of the shot. Let's say it's an exit shot. So immediately you're met with these settings, and right now you can see it's on FPS. And these are the limits. You have the 5 seconds here. And you're playing with just 5 seconds. And usually this is fine. If you need to adjust it, you make it 12 and 10. So these are your extents. And then bring this all the way to, let's say, 10. The red bracket. And then you add the camera where you need the camera to be. Add cinematic and then cine camera after. So it falls on your screen as you need this way. And then you just need to point it to wherever portion you need it to be pointed. So in this case, this is Cine Camera Actor 5. I just have to drop this in the sequencer and unpilot it. So have it pinned here at the side, and this will show how it's doing. So you can play with keyframes in this section. In this case, there is a transform node. And let's say at this point, we'll start at this location. And then at the next point, make it move in the X direction. What I like to do is I like to make the movements very smooth. So instead of having it in circle icons here at cubic auto, I like to change it from cubic to linear. So that if you press play here, if you check, it's moving very smoothly this way. So with this sequence, you just have to save it. Save the sequence and then open Windows and cinematic, and then click on movie render queue. And you have this tab here, and all you need to do is click the plus render tab and then add whichever sequence you created. Let's see, sequence biome exit, and then you have settings here. And then this is the output directory. You just follow where it is to be able to locate it. And then right off the bat, I'm okay with the settings, but then I'm just gonna change the resolution from to 4K by changing it to 3840 to 160. And then making sure that I have handle frame count on, because what it does is you want to give the Unreal Engine ample time to prepare before rendering. So I like to put handle frame count at 5. I moved that by accident. And then accept, and I'm good with that. Just have a 4K render, and then make sure that uh you check your sequence and maybe add the camera cut. This is the camera cut. Just make it a little bit over, and a little bit under to the side so that you don't have renders that are just cut. And let's try rendering it and see how fast it renders. So let's have this one clip. You can have many clips as much as you want. But I covered here the basics of having a camera, putting it in your sequencer, having it move, and if you need any reference with the atmospherics, I really laid it out here for you guys to follow, because I still follow this day. I can't memorize it. So just please return to this. So let's try rendering this the biome exit. So render local. Let's see. I clicked on render. So right now it's at 10 seconds. So 10 seconds at 24 FPS is 240 frames if you look at it, but we have a handle frame count, which prepares the engine before and after. So there's 5 frames before and 5 frames after. So that makes it 250 plus 1. So right now it's rendering as it moves. And now I just wanted to check if it renders properly. And yeah, it is. So I also wanted to fast forward to show you the output in itself. And you can find it here. Either you go to unsafe config and open the directory. You can see it here. Or it's usually at the engine folder wherever your Unreal folder is, saved, and then movie renders, and then all your renders are here. They're all in frames, and you can process them in whatever video processing you use. In my case, I use DaVinci Resolve. I just drag this in this whole set, and it recognizes it as one video. So let's see, zoom out. So these are the rendered frames. I stopped it right at the middle. So this is what we have. But if I finish the rendering, it's just that quick. 10 seconds would probably take 2-3 minutes to render. A lot faster if I'm not streaming this like what I'm doing now. So yeah. So that wraps it up with everything you need to know. I'm really apologize if I took I think I'm taking an hour and a half extra. And I think Mike, if there's any Q&A, if there's needed, any Q&A is needed, Mike.
Hey everyone, yeah, thank you so much for the webinar. If anyone has any last questions, ask them now. Uh, if not, we'll end it here and recordings will be sent uh, when they're done processing.
I think that was just I think too much to pack into 5 hours. There's a lot of concepts there. I mean, me myself when I was doing it, I was thinking if it could really fit the 5 hour mark. But it was important because this is a workflow that sort of bridges gaps between the procedural and environment art. So I thought it was really needed. And
Yeah,
yeah,
yeah, it was awesome. As you can see in the comments, people are happy about it. So, yeah. I guess if there's no more questions, we can end it. And I know it's late for you, Alab.
thanks so much, everyone. I know it's sort of a tight-knit group. We don't have much participants, but I guess because it's sort of on a more advanced level, and maybe that's the reason. And I appreciate you guys for staying till this long. I don't think much exited. I don't think I can listen to myself for that long.
Yeah,
All
yeah,
right.
yeah. Not my, but yeah. There's like a few that stayed the whole time, which is
My gosh.
cool. Uh,
Yeah.
yeah, it's
So
okay.
again,
Yeah, they have all the information before anyone else.
yeah. So I have there's the handouts. Downloads are available for you. Um, Maybe if you're gonna render it for yourself, maybe just tweak little stuff, not just have whatever's prepared, and then look at the files and iterate as you need. But I found that this is a sort of skill that I use a lot in the professional environment, at work, in different applications. So good luck to you guys and thank you so much.
Thank you, everybody. Thank you, Alab. Till next
Thank you so
time.
much. See you.
See ya.